Zoom, it's going on correctly. All right. So just a real real quick review just by going into an exercise. So what we're going to do, let's see, coordinates. So let's go ahead and load up Carlson. And once that loads, we want to open a file. And let's go ahead and open the, go to the folder we were working in, go to our data set, and we're going to open wrong one. Oh, coordinate file there. Let me go. Let's see. Oh, okay. That's what we're doing. All right. So instead of opening the file, I'm going to cancel that. I'm going to just make a new drawing. My apologies there. And I will just take a bunch of the defaults here. I'll go to a drawing type. I'll use a template. And there is my National CAD Standard Civil. I will use that. It doesn't matter at all which one you use because we're just going to go from an empty one and look at some coordinates. I'm going to start at the top here and choose my new drawing name. And I will put that now in my data sets folder. And I'm going to call this coordinate. Let's see, it's capital letter so you can see it. Coordinates exercise 1. And I will leave that at 50 scale. I'll make my symbols a 10th. And I'm not going to set a projection here at all because I'm going to have just some arbitrary coordinates and some data that we're going to be using. So I'll just leave that set to none. I will say next. And now for my coordinate file, I'm going to do like this says on page 13 of our book. We're going to use this file here called exercise 1 coordinates. Okay, so another good point of illustration here is that this is not required that it names the same as the drawing file. So I'm going to choose, before I hit the set button, I'm going to look at this coordinate file choice down here. I've got new and existing. I want to make sure I choose existing because otherwise if I say new and hit the set button and find that file, it will right over top of it. It will warn you for it before you do it. But if I say existing and then hit the set button, I want to use that exercise 1 coordinates. That. And I will do import points from, set it to none. So next. Okay. So everyone should have essentially a blank drawing. And we've just opened a coordinate file. And a couple of things to note about that. When you have a drawing open and a coordinate file associated with it, you'll see that information up at the top of the screen. This tells me I'm in Carlson Survey 2021, and tells me my CRD file, my coordinate file is exercise 1 coordinates, and then it has a .crd extension on it, but it doesn't show that to you. But this drawing file name is the next bracketed item, which says coordinates-ex1.pwg. So that lets me know what I'm working in, where I'm working. And you can also, you may notice that there's a little asterisk up here by the file name. And I'm not sure if that is also available in AutoCAD. I think it does the same thing in the AutoCAD version. But what that's telling you, if you ever see that, the only thing that's telling you is that you've made some change to your file, even if you just changed the zoom level and it's not saved yet. So if I go over here and hit my save icon, the little diskette, see how that asterisk goes away, both up there and here on this tab. So anytime you see, if you've got a bunch of drawings lined up open at the same time, and you've got these tabs showing, any of them that have an asterisk by them means that you have some unsaved changes in that file. Okay, that's all that means. All right, so now there's nothing in it. I did a zoom extents, either Z enter, E enter, or some shortcuts might be ZE. I'm not sure if ZE works. Right, yeah, it looks like it does. Or you can double click the wheel on the mouse. All of that stuff works fine. But so where are our coordinates? And the answer to that is, well, we haven't put them in the drawing yet. But they are in our file, and our file is associated with our work session right now, this exercise 1-coordinates. And we can tell that when we look at the points menu, if you list points. So I'm going to list this points. I'm just going to leave it set to range as a selection. And my range of points, I'm just going to say all. See, there's a keyword there, all, or you could say 1-5000. So even if there are points that are not in that range, you know, if your range is smaller than the range you put in there, it doesn't matter. It doesn't give you any kind of an error. I'm going to check a couple of options here. I will report the range of coordinates and any point notes that I may have. Now, I don't have any in this one. I'll go ahead and report the job header just to show you what that looks like. And let's see, coordinates in inches, no. I can set the decimal places, how many I want. I'll leave it at that. My description match up here in this field at the right underneath the first couple of buttons there is an asterisk. That means anything, everything is a wildcard, and I'll hit OK. And up comes my coordinate listing. And here's what a couple of those options were. When I said print the job header and all that information, it's going to give me my job description, which is blank, a job number, which is 0 in terms of a number. So that's all it is just something from the report settings. And I've got points numbers 1 through 22. I've got northing values and easting values and elevation values. And I have a column of descriptions, which, however, are all blank at the moment. Okay. Down below here is my coordinate range. That was the checkbox that I did. So it gives me the minimum and maximum X, Y, and Z. And it tells me how many points I have total. So now they happen to be sequential. So I can look up there and see 22 is my last number, but you can have gaps and all that. It just gives you a count of the points. Now, still, they're not in my drawing. I haven't located them yet. Let's go to the settings menu real quick and go to the drawing setup. And let's go down here to content. Yes, go ahead.
If I got no points in that report, where did I go wrong?
You did not get the file. Anybody else? Anybody else in that situation? Okay. So Ed, if you got no points there, go to your points menu first of all and choose set coordinate file. And when that comes up, make sure you see these tabs at the top here. Make sure you choose existing and choose that exercise 1-coordinates file that shows in that list. And when you see that in this list here, when you sit on a given file, look, notice over here in this little preview window, it tells you I've got points 1-22. The next file over here, I've got 1-144. So are you seeing that? Are you seeing that 1-22?
Yep, now I see it. I got it.
And then go ahead and hit open. And then that will associate that file to it, and then go back to points and do your list points and make sure, and you can just leave it at that or change that, hit the all button and hit OK, and it will show you those values. Okay. Now.
Okay, cool. I'm back on track.
Okay, good deals, good deals. All right, so let's go to the settings menu in the drawing setup. And just to show you where this stuff comes in, and it's just header information. Let's go to the project name. Let's give that a name. Let's just call it class. And I'm going to give it a job number 123.45. Location, so Pittsburgh, and just something like that. We'll say okay. And all I've done really is set the set those fields to some values. And now if I go back to list points, and I'm not going to change anything at all, I'm just going to list all points. I've got these things checked to report the job header, and that's what you're going to see next. Is here's my project, here's my location, and here's my job number. Now, why it gives us that line twice here, I don't really quite understand. And I think that's a bug that used to not be there. It's there, it's doubled. But however, here's what I want to point out about this thing. This is nothing in the world more than a simple text report. Okay. I can take this report and, well, I see a couple things I might want to do with it. If let's see, let's take I'm going to, and what I'm doing here is just putting, I'm just clicking down here and, just like a text editor. So I'm actually actively editing everything. And you can see what I'm really doing is sort of trying to line up my decimals. Okay, there's no need to have to do that. I'll show you something else when we get back out of this. But you can see it. I won't do any more there. I'll come down here and maybe spread that out. You could, these things, say I want to keep the job date. I'll just take that out. I would say I don't need all of this path information right here, but I will call it Just edit that down to like such. Let's put that right there. Maybe like that. Let's call it. All right. And now from these buttons up here, you can do, save this as a text file. Right now, up here at the top of the stripe, you can see that that says scadp or scadrprt.tmp. And that's a holdover from many years ago, back when it used to be called ServCAD, the ServCAD report, and it's a temporary file right now. But you can save it, make it permanent. You can print it. You can do a find, like a search and replace, like a text editor. But you can output to the screen. You can also hide. I'm not sure what that means, just detaches it. But notice you also have this command right here. That's append to. So if you are running a series of reports, and it doesn't have to just be coordinates, it can be pretty much anything. Let's see, make that. Oops. Yeah, you get the idea of what I'm doing there, sort of making up a report. This thing I could put, bars and lines and stuff, etc. But you could have, when you run a report of, even if it's a volume calculation for earthworks, or you're doing stockpile volumes or something, you can run a report and then you can append that to another file that you've already done, and just generate a composite report, that you've done previously. You've got search and replace, like I said. You've got some settings here, some options, whether you want to use the print settings that the computer has set up. That's normally what you would do. Use degree symbols. If you had a report that included angle values, it would use the degree symbol. Otherwise, I think it just puts a lowercase d. And this sets up, basic minimal type information for the printer, margins and lines per page, etc. And then the printer font and the editor font, you can set those to be either what you're seeing here, which is called monospace 821 BT, and it's 11 points, or you can set that to be anything that you want. Okay. So again, what other use for this is, particularly a lot of surveyors will have to, print the coordinates in their file. So one thing you can do is output that to screen, output to the screen, and that's available on the file screen button, or this one right here is the same command. So I'll click that and it's going to ask me a little dialog box. What do you want to put it out as text? In which case it's all of those individual lines of text, or multi-line text, one paragraph, multiple lines, and then the height, what layer to put it on, what style to use. Now that's sort of like the font that you saw in the setup. I'll explain that difference here in just a minute for those subtle CAD difference. And then what layout it goes to, either model or layout 1. And I'll explain that here in a minute. Now yours may not have that choice if you're running an older version that's fairly new, that you get that choice. But what that means is down here at the bottom of the screen, you see these two tabs, model and layout 1, layout 2, layout 3. Whatever you happen to have, and they can have varying names, etc. But model is the actual model space where everything is exactly the height that, or is the size, in real world ground units. Whereas these layout tabs, that's where you have your printed pages and your title blocks, and they're typically set up in terms of inches, and they're actually created at a different size. Now, because of that, this height value up here is not the same like the plotted text size where we typed 0.1, okay, or 0.08 or something. Now it calculates out to be based on, I have a 0.08 default text style. I'm at 50 scale. So so it goes ahead and tells me, all right, I'm going to create this text height of 4 units on the ground, 4 feet tall on the ground at 1 inch equals 50 feet. That will give me that 0.08 tall text once I put it in the screen, put it in the drawing. So that's why it's left as a real number, because if you change this to a layout tab, that's in paper. In that case, it's going to be in paper inches. So it depends on which of those that you're going to choose. So it doesn't know which one, to ask you for. So it's asking you for the actual height of the text itself. So I'll say, okay, and I will, it's asking me to, down here at the command line, to show it the start point, or choose center, middle, or right. And that's the justification. And I'm going to just click the point. It's by default, it is left justified. So I'll just click right here. And now, see, I'm still not through. It's asking for more input. It wants to know the rotation angle. And right now, by default, it's east, which means 0 degrees. So I'll just hit enter because that's the number that's in angle brackets. That's my default. The report pops back up for a moment and stays there until we exit that report. If we're done working with it, we say, okay. And now, because I'm zoomed way in, here's my report. Now I can select it, grab that little grip, move it around. I can, if I double click it, it's not going to let me. Who else is doing, let me see. Joe, was it you that, who's using the 2021 IntelliCAD version? All you guys?
I am.
Okay. If you double click this, does it load up the editor, the text editor?
I double click it, it just puts a little box around it. Oh, but yeah, then I can edit it.
Okay, see mine, and that might be this new update. I just double clicked that and it's not, see, it doesn't let me do it. If I select it, let's see what I can do here. But I can choose it from the edit menu, and that brings that up. Now that's what I wanted to see. And I can open up this ruler and make all that. I don't know why it's not responding to double clicks, but anyway. So at this point, you are in the IntelliCAD editor, and you can take individual lines, change to, different sizes, just like a text editor. So you can do, all kinds of different things that you might want to do. You can then, because it is a monospaced font, that's how you can get these, and these are just spaces in between. So I can get my, well, that's actually not a monospaced font, is it? But anyway, you can see what you can do with these values in terms of getting them to, to line up. So, I would possibly put all this stuff in and maybe change those to tabs instead of spaces to get all these things to line up correctly. However, I wouldn't necessarily do it here in this. I'm going to show you that here in just a second. But so there is that. If I told you also I was going to explain to you the difference in this text, the CAD style mono versus the actual font that it's using. So I've got, right now two styles in this drawing, one called standard and one called mono that it created. Now standard, you see the font changed. It's an Arial font. So that's just reading that standard or reading the definition. So I'm going to say okay to accept those edits. I'll hit enter. And now let's look at where that is done. And if I go to the, so we put a draw text, and this says standard. That doesn't mean standard style. It just means that's the standard text command. But when you draw on the draw menu, text set style, that's going to type the command, the style command, which lets you define text styles. Now, text styles in AutoCAD are just whatever you want to name them. And there's so many people that use AutoCAD that they name the text style the exact same name as the font that it's defined with. And that's not really, I mean, it's okay to do that, but it's not one and the same thing. Like you'll see styles available sometimes. You'll see a style called Roman S and Simplex and all of that. And those are really just the name of the font file. But a style is a definition that includes a font name. So I'm over here in my text font list. And I'm going to, because I'm defining this mono style, I'm going to scroll down here and find my monospace 821 BT. So monospace meaning that, all the letters are the same width, even the letter I and the letter W, they're all the same width. And then you've got different styles, italic, bold, Roman. And you get those types of things when you're using true type fonts, which you can tell with the TT up there. The typical, normal, and what used to be years ago, the only fonts that you could use were CAD fonts. And those are the ones you see with this little other symbol, and they have an SHX extension. That is a shape file based font. Okay. So I'm going to change that to that monospace. A couple things about height. If you define a text height, then that style, anytime you change text, it will always be set to that particular height. And this height happens to be ground distance, not that 0.8. So if you do define it, that's what it's going to be. If you leave it at 0, then you can set the height as a property of this text. Otherwise, you can't set that. It's already defined. The width factor, that's just simply if you want to make things, spread out. And that means the letters themselves are actually stretched. Or a lot of times you'll see people put in there like 0.8 to compress it a little bit. Just to keep from taking up so much width. But anyway, this will be all I'll need. I'll say, okay. It tells me it's been modified. Do I want to save the changes? I'll say yes. And now this, when I select this, when I edited it, I changed it in the editor and set the style, and that was standard. But if I switch it back now here in my properties to mono, I've got this. Wow, I have no idea why it won't let me double click edit that. But in any case, these things are well, it's supposed to be monospaced. It doesn't look like that is a true monospace font. Fix that. Let's see, why is that? Let's see. Select everything and let's change that to that and then change this back to mono. Why it's not doing that. All right, so there's my monospace BT. And now there we go. Okay, so you can see how you can make this into a nice little column type report. And you know, just get those to line up, get your header bars over your top, you know, that kind of stuff. And that stays then as part of your drawing. So you could have your property map and set your control points and have a listing of control point data in your map, for instance. Now, the other thing you can do with that report, instead of doing it with that report viewer that you saw, that default text viewer, let's go back to points and list points again. And this time, let's go down here to this checkbox that says use report formatter. And if we turn that on and choose OK, up comes a different dialog box. And you can actually create a formatted report that's of any order that you like. You could even add, say, an average elevation in. You can choose, let's put the description first. So if I select that description line, bring it up here, I can do that. If I double click either one of those, it toggles it back and forth between fields that are available and fields that are used. So I'll put that back up there as the first field. If I select it and hit edit, it lets me change the heading. It tells me I can do some tabulation on these things, like I can do a total. So if I want to total up my point numbers, do that in a minute. Tell it whether to use text or a number or a date, or go by default. That's a cell format. See that in just a minute. You could have it advance a line after the field, which I'll do there. I'll set that to text. Automatic width. Here's your different styles. So we're not going to go through all of that, but just to show you what it does do. And I'm going to take my point number. I will edit that. And I'm going to do my total. I'm going to count. Let's say I want to make that into a number. There we go. It's not really. It's not the point number itself. It's the count. That's what, if I look down here, then if I say include totals is checked on, I can get a grand total or a grand total descriptions, point numbers, and all of that. So you could You can see what that's going to look like here. I can make this into a columnar format. I can display it as header information in my table. Again, not going through all of that stuff. I have these output tabs as well. I can output to edit these different settings in the report. I can export, merge, save. You can even create GIS data. Here's an ESRI MSD data. I've got an Excel tab. I can export that to Excel. If I put it back on the report tab, I can look at some previews with my display button. And there's the display, which is, again, back in that same text type report. Or if I say spread view, this is my spreadsheet type view. You see the columns and the cells. You notice I put the description first, remember, in my definition instead of at the end like it had it before. You can also say click on, I guess select the whole cell. It's not going to let you sort it at that point. You can drag these over for different widths. If you choose export, it will create an export for that either in XML or a CSV, comma separated value text file, or in Excel, or as an Access database file. So there's all kinds of things that you have available just from the spreadsheet view. If I choose HTML report, that's going to actually go out and use a report definition that defines the fonts and the tables, and it puts it into a chart. You can save it. See up here, it's an HTML file. And I'll close that. This table entity is much like this over here that was just text. But if I choose a table entity, when I exit this, it's going to put it over here. Okay. I've got my report viewer, and this lets me define page sizes, margins, etc. And I'll choose OK. And you'll see that would be that same view. Now, I'm just in a preview at this point, so, but it would be that same type of report that I could view. All right. And again, over here, I can simply make a Microsoft Excel spreadsheet. And here is the actual Excel file. And that finds that as long as you have Excel installed in your system. I will select this and make it, I'll say, right justified. I will select these, set their widths. Okay. Again, right justified. And then I'm going to take those and put a bottom border on that. All right, then you can actually bring this file, an Excel spreadsheet, into your drawing. So it's really a quicker way, and that would be the way that I would go about doing this instead of using that text thing. I'm not going to say this. So you can see all the different things that we can do. I'll say exit and pick a location for the table. There's a table. Again, I make all kinds of formatting rules. I'm going to just hit OK and let it read. And there's a different thing. It's sort of like this over here being in text, except now this is a table. Double click that and you can go straight to your editor. I could take out these blank lines, make some different things. Here I can even do define that as? I can't. Yeah, I can sort on these different columns. So it's much like a spreadsheet would be, but again, this is an actual CAD table opposed to that. Now, again, remember, this is all about any report that we do. And here's another thing to remember when you're running this stuff, because you'll be in a hurry sometime and you'll forget. If you run, you draw, locate, or not, sorry, draw, locate points. If you list your points and you think you're just going to get that text report again, it sticks to use this report formatter until you uncheck that. Okay, and so now it's going to go back to this text view and to put it, you know, to keep from having to go into all of that formatting work all the time or to try to keep track of it. But any of those things is fine. It's available for you to do. Okay. So now I will just select those things and delete them. And again, now I've got nothing in the drawing, but I see that I've got some points. Okay. So how do you get to points in the drawing? And again, you might have already looked ahead and figured out. You go to the points menu and there's a command called draw locate points. And that's going to do the yeoman's work of placing points in your drawing from a coordinate file. And you see up the top, it has a listing of the file, and it is by default set to the one that you set when we opened the file. You can change that. You can change it right here and look at a different set of points if you wanted to. Or you know, if for whatever reason, maybe somebody gives you another file that you need some points out of, you need a few of them, and you're not going to take all of them. You come down here in the middle where it says wildcard description match, and you could set that to be some kind of a filter of the list of points that you're going to bring in. But notice what's coming up here. I've got a symbol shown. Mine's a circle. I've got a bunch of these things checked already, and some not checked. I've got using point numbers, automatic point numbers. What point number do I want to start with? Okay. And that's not going to have a lot of effect on reading some existing points and putting them in my drawing. It's going to take whatever point numbers that file has in it. But if I were creating new points, because this is a command, this is draw locate points. So I can actually create points with this, even if they don't exist yet. In which case, you can see these buttons down below help me do that. I've got enter and assign, which will prompt me down on the command line to type in the values for northing, easting, and elevation. And by the way, too, for those of you that are not familiar with typical CAD parlance versus surveying parlance, when we talk about coordinates in Carlson, they're almost always going to be asked for or reported in northing first, then easting, then elevation. And the northing, that's the term we use for the north coordinate. How far north are you? How far east are you is the easting. We don't have a heighting, or we don't have an elevationing, but so northing, easting, elevation. But the CAD system, because the CAD is not really aware of the fact that you're a surveyor or you're an engineer or you're working with coordinates, all it knows is a three-dimensional coordinate system like a mathematician would use. And that's why those coordinates are always in X, Y, Z order. So just keep your eye on that when it asks you for points. If you're doing something and if they ask you for a point on the command line, but it's the CAD system asking you for the point, like when you go to draw a line or a polyline, you want to draw it from here to there, and you've got a coordinate that you know the value of, you need to put it in sort of in backwards order. You put the Y value first, that's the X value, and then you put a comma, and then the north value, which is the, I'm sorry, you put in the X axis value, which is the easting. So you put in the easting first, comma, then the northing, comma, and then the elevation. If you are responding to a CAD type command, but when you're using a Carlson type command, you're most often going to be using northings first. Okay, so just be a little bit aware of that. So now, because I've got these things showing up here, where do these things come from? Well, I can change them at any point. If I just click, can I click that symbol? Oh yes. Something went awry. Now, if I hit my set button, that lets me change to a different point symbol. That's what I was trying to get to. I'll just use these X's. And so at this point, some of the things we can do is down below here, I can type a layer name. I can click select, and I can pick that from a list of layers. Or, and notice my layer, they may not match the same as yours depending on what template you started with. I could even say, instead of that, I could type in a new one. I'm going to use one that is typical. V node, V means survey, node meaning point, and I'm going to call these coordinates. Now, that layer does not exist yet, but Carlson doesn't care. It will make it for you when it needs to do that. Okay. And I could draw a range of those points or draw them all. We'll talk about drawing a group a little bit in the next exercise. I can enter and assign. That lets me choose this starting number and type in those values, or I can screen pick, which lets me pick locations in the drawing with the mouse, and it creates new points when I do that. But I'm just going to choose draw all, and it's going to read the file, and it's going to draw the points. Now yours will probably be much faster than mine for whatever reason. I think it's a graphics card issue. It takes a little bit of time to draw that. So now what do I have? I've got point number 1, 2, 3, 4. I can see those when I zoom in. 5, 6, blah, 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 all the way around to 22. I see point numbers. I see elevations. I do not see descriptions. And I also see what this point actually is that it is a combination of a CAD entity point, which is just a dot at the intersection of that X looking symbol. It is a graphic block, which is that drawn X, that was the chosen symbol. And it is a what's called an attributed block, or it's a block of attributes, which includes the point number, the elevation, and the description. So if I select one of those, say number 22, and I'm just going to go over here in my properties, and I can see I've got the blocks here. You see it's telling me there's 2 blocks, and there's a point. So if I can put those on different layers. I can, change their coordinate values and such here. This little icon next to those numbers means I can click a spot out in the drawing.
What's your problem? I'm busy.
What's that?
I'm sorry, Ken.
Oh, okay. So these are all a number of, different things that you can work with. Now, you can do all of these commands on the points menu we've already done that list points. If we edit points, it brings that up. I can do all kinds of changes here. I can sort, let's say if I wanted to see the points, here's my, I can sort by these different, here's sorted by elevations, or I can sort by point number, which you can see 1, then 1, 0, 1, 1, 1, 2, 1, 9, then 2, then 2, 0. So it's not, a real exact sorting mechanism. Now that does not change the file. That's just while you're editing, it lets you sort those out. But you've got, find and replace, all kinds of things just you can do with that editor. And that's a spreadsheet type editor that takes all the points. Or you can, let's see what we can do. You can do this adjust, and these commands used to be out on this menu, but there's so many that you can do now that it's got it in a pull right. So that's just where you can do translate, which means to move them X and Y, horizontally, well, I guess vertically as well. Or you can rotate them, and that's simply to change the orientation of them on the screen, not to move their position around the different circle. Scale them, align the points. You can, here's the actual move where it'll take the move itself. Or you can do a complete full-on coordinate transformation, which includes, a latitude and longitude points, if that's what the values are, to a grid. You can do, a grid to lat long. You do local coordinates. From screen entities, input from their point numbers, or you can enter coordinates and it will output to whatever you choose as those types of options. So there's a lot of mathematical things you can do there. You can also simply, because it is a CAD element, if you select it and then just grab that middle grip, the one on the point, and just move the point on the screen. Just select it, get the grips on, select the grip and move it. Or, and I'm going to say, yeah, I'll update that location. And then if you undo that, so I'm undoing it, it tells me that I've changed again. So yes, I'll update it back. You can also, again, with just a CAD command, I can select those, right click and choose move, put them up there. And again, it tells me things have changed, and it would ask me this for each of those points, or I could just say yes to all or no to all. There that went. I'll undo that again. Now, what happened there? I hit the undo, they went back, but it didn't give me the warning, did it? Because that particular command, moving more than one at a time with a CAD command, did not trigger the change detection, but it will be triggered. Now I said yes when I moved it up here. I undid it, but now the coordinate file thinks it's up here. This is now down here. So if I double click a point, so that one, it's looking like they're back. It's looking like they are back where they wanted. It just didn't give me the warning. It just went ahead and updated it for me. Now, the other way of editing these points is like I was just doing here, is if you double click a point, it puts a little marker as to where it reads the value of that point inside the coordinate file. And then inside here, you can change the point name, which, in our case, they're all numbers. You can type in values here for the northing, the Y value, the easting, the X, elevation, or Z. Tell it how many decimal places you want the elevation to display in the attribute out here. And you have two fields for description. You have a drawing description and you have a coordinate file description. Now, this is going to be sort of hinting at the way field to finish works, in that you can read a coordinate file description, the CRD file description, and based on that code, and they're typically, cryptic 2 or 3 letter codes like EP or EOP for edge of pavement. And then you might have, say, we'll call this edge of pavement spelled out, and then down, and it could stay blank. It doesn't have to be anything, but I'm going to call that P. Now, there's also this box right here. This is non-surface. And what that does, it allows you to keep that elevation. You don't have to set it to 0. You can keep that elevation. But if you say non-surface, even when you select the file to, or select that point to make a surface file, it reads that flag and won't use it in the triangulation. Okay? That's useful for things like if you've got a benchmark like a railroad spike driven in a telephone pole about 1 foot off the ground. Well, you don't want that to indicate the ground elevation, but you want to keep that elevation, or maybe you shot the top of a fire hydrant nut, and that's going to be your benchmark. So you don't want those to be surface points, but you do still want to keep these elevations. So that's not the same as setting it to 0. Again, symbol. So you could change, let's say that, that was that's my edge of pavement. I would typically not put any symbol on that. Or if it were a horizontal control point, scroll through to try to find it. You get the idea. I'll just change it to that. I can put notes here, just typed notes, and it's just data that associates with that point number. And this is typically things that you would find from coming in from the field. Okay, so you would be out there when you're collecting your points in your data collector, you can add a note to it. Maybe if you're shooting a manhole rim, you might put in a note that says, spot on rim, at north, or 2 o'clock, and with north being the 12 o'clock position, around a clock dial, depending on how you might do that. Or you might put recovery notes, anything in there that helps you to work with that point for future use. Now, that stores in a file that is the same name as the coordinate file, but it has an NOT extension on it, and it just links those 2 files together. This, if I choose the GIS tab, see, that tells me it requires a CRDB format, not the CRD format. So this is a complete actual database. It is an SQL-lite database format, and not that CRD format, which even though it's binary, it's just only understood by Carlson. These types of formats are actually full-on database files, and if we have that file shown, I could have GIS attributes on these points that I shoot out in the field. I could be, again, if that's a manhole, maybe I could establish, I could store in there the utility type, whether it's sanitary or storm sewer or electric, or whatever. I could put in a condition assessment, poor, fair, good, new installation. I can do telephone poles. I could put a utility pole number, anything that I want to do, and I can have one, I can have none, I can have many. However I define those GIS attributes, I can even set up my data collector to, when I'm out in the field and I pick up manholes, it's going to prompt me to put those things in there. And that stores directly in that same single file. Now, we are not using that file format in this particular example. It doesn't matter. I can still use GIS data, but in that case, it links a separate file, just like the notes file. It links a .gis file to that CRD file. So you have to have those two files together in the same directory, and it will read all that stuff, show them to you separately in your GIS tools. Otherwise, you can track this GIS stuff straight here without even needing the GIS module or the menu commands from Survey. You can establish, you can add an image to that file. So if you took a picture of, that, say it's a recovered monument or something, you can tag that image to it. And over here, the settings, which I presume they're going to have some future use here. Right now, the only thing that it's going to let you set is the number of decimal places in the editor. And that's this right here, the general tab. All right, so I've now changed point number 21. I've made it some drawing description and a coordinate file description. I'll say okay, and there it is. Now you notice it changed that symbol. It changed, it added this as a drawing description. And again, if I double click that, you would see those two things there. Now, let's go back to the points menu and let's edit the points, and let's scroll down here and find point number 21. And I see, well, that description doesn't say edge of pavement, it says EP, because remember, that's the description in the coordinate file. Again, double clicking it, CRD file description is EP, drawing description is edge of pavement. Again, that's the foundation of field to finish that lets you read that EP code and tell the library that when you see EP, I want you to put edge of pavement in the drawing. So you don't have to type all that stuff out in the field. And there's a lot of more things that it does as well, but that's just one difference. Now, if you happen to need to redraw that point, you could go back to points, draw locate points, and I'm going to draw a range again instead of draw all. And I'll say draw a range, and down here in the command line, it's going to prompt me what point numbers do I want to draw. I'm going to say 21. I'll hit enter. Now, see, it goes back to, and I'll hit enter to finish that up. It keeps asking. So now, you see, it read the CRD file description and it used that up here in my drawing description because I didn't tell it anything otherwise. If I had, it would have changed it. Okay. None of these other points have descriptions. That's why you don't see that line down there under the point number. And take a look at this. If you zoom in there and you get kind of tight, you see those numbers, which we would expect a 2 to be nice and smooth. Same thing with the 6, this 0 up here for 20. That is because that block is using an attribute that is defined with a particular text style. Remember before when we were looking at the report, we had 2 text styles in this file. We had a standard and we had that mono. And you may have many, you may have only one. Depends on it, and that's depending on what is in the template file when you start up. Now, this particular set of the font here is called that's called std.txt, I believe, standard text. But anyway, you see how those little square edges instead of round things? That's because this was developed for CAD systems way back in the day when we only had pen plotters. And it was much faster to have a pen plotter draw little line segments instead of, drawing an itty bitty teeny tiny part of an arc and go around. We didn't have dot matrix type printers or inkjet type printers in those days. And so that was an efficiency thing that made it quick to draw those fonts. It's what I like to call, ugly text. I don't like the look of that. I don't like to use it. So what I do is, now that it's there, I can either go here after the fact and go to the draw text, set style, or I can simply type the style command. Or if you're using IntelliCAD, you can use this button right here under layer control, also available under view layer control. And because this is my little central clearinghouse for everything, not just layers, I come down here and click the text style button, and there you see that text called PTXT, which is, oh, there it is, txt.shx. So I have a style named PTXT that uses this font called txt.shx. I see that mono, for whatever reason, did not update when I did it earlier. We were doing the tables. All right, so now my P text, I'm going to, instead of using that particular font, I'm going to use one that I think looks kind of lean and nice called Calibri Light. So I'm just going to redefine the style and close that off. So now you see I've got some nice looking font text that I could use as part of my drawing. And I often do use, when I use points, I'll use the symbols and I'll actually use the descriptions as part of the labeling in my drawing. Now, let's see the surveyors here, Zoe and Joe. What is typical that I find out there in a lot of surveying companies is, yeah, I've got these points, I'm in my drawing, but I'm not going to put those in the drawing because I got to give my drawing off to my client. So I don't want him to get my coordinates. I don't want him to get my, values, but I'll draw a label to whatever it is, and I'll put a, I'll type in the text of what that's supposed to be, and that's perfectly fine. Because if I'm going to keep these and use these in the DWG file, that could be a recoverable coordinate that they could have access to. It's it's just a matter of preference and that sort of thing that some people have. All right. So again, that draw locate points. That's where that was. I was able to change that symbol. Different options here, automatic point numbering, yes or no. I've got this right here is a one that's very important to sort of keep track of. If you have duplicates, you can allow duplicates, and it will draw multiple versions of the same point number in the drawing if it already has points there. Or you can say erase and redraw. That's when that edge of pavement went away and it came back as EP this time. Or you could say, well, if you're going to be a duplication, instead of redrawing the duplicate, only draw the new ones. So that's a choice I could have set, and it would have kept that old description here because it would not have redrawn it because it was a duplicate. And again, setting these layer names, all kinds of different things that you can do with that. Now, the one thing that I noticed on mine, because I don't particularly care for that layout that it uses, I like to see my points in a different fashion. And that comes from not the draw locate points, but from my point defaults. So right up here is that layout that it's using right now. You see the point number is over the point, which is just a space there in the middle, and then the elevation off to the right and the description underneath it. So I'm going to change that to the one that I like. where it lines them all up on the left. Now notice there are some even that change the order. Elevation is top, the point numbers off to the side. Here's one that you mapping people might notice. It's going to put the point symbol and put the elevation up at a 45-degree angle beside the point symbol. And if that's the case, I'm going to go ahead and say okay to there. I've set that default. Let's go back and draw, locate my points again. And this time, instead of using point numbers and elevations, I'm going to uncheck. Oops, I guess I can't do that one. Or if I uncheck the description, yes, let me see if I uncheck that. Yeah, okay, I'll uncheck the point numbers, which unchecks the descriptions, but I'll leave the elevations on. And I'll draw all, and we'll see what it changes them to nothing. That worked nicely. Let's take points. Yes, I need. It's not. Yeah, that should have put the elevations in. But here's what can happen if I'm going ahead and putting the point numbers, the elevations and descriptions. So now they show up like this. So what does this do for me in terms of like a map that I'm creating, like you'd see like spot elevations shown that way? But I've got these other two things here, these point numbers and the description. And I don't want to see that. I only want to see the elevations. Well, we can freeze off those layers. If you go back now and look at the layer list, and if you have not defined them to be something else, the default that you're looking for is going to be alphabetically in order. You've got a PNT, DESC, ELEV, and NO. That's point description, point elevation, point number. Those are the default layer names and colors. See, there's white, which would be black on a white page if you printed it. Sorry, you've got the elevation is blue, the description is green. You can change all that. You can create those layers and save them in your drawing template so it's there all the time. Or you can see where that is. You can then freeze those particular layers off, and you can do that either by going to that layer manager, scrolling down to those layers and hitting the freeze tab, or go to your layers toolbar up here at the top of the screen, or go to the view menu and just say freeze layer by pick. Pick the point number, pick the description, hit enter when you're finished. And so now you're left with, maybe the way you want to draw your attributes on a, say, a spot elevation on a map. Okay. So I'm going to go back again to my point defaults and change that now finally to this attribute type. And let's see if I can. If I turn off point numbers and turn off descriptions, even with this, I say okay, and then redraw locate. So descriptions is unchecked, point numbers is unchecked. No, it still won't do that. If any of you are using a previous version, that may still be working. That's another little bit of a bug. So back to my defaults, turn on my point numbers, turn on my descriptions up here at the top. There's that. That's okay. I'll locate one more time. Draw all, and now they'll come in. You'll see what that's. separate attribute layout. Okay, now, when you have some points that are maybe too close together, or they're they're so close together that these labels or these attributes get in the way with each other, that's one of those checkboxes right here under draw locate points that you can turn on right here on the right hand side that says fix overlapping point attributes. And when you do that, if when you draw the points, it notices in the drawing file that they overlap, it's going to show you that and ask you how you want to fix it, either by repositioning the attributes a little bit away from each other or along a line, or pull it away from the point and put a leader into it. All of those different kind of things. It can do that automatically, but I will warn you that that particular type of processing takes a little bit of time to process, not terribly much. Some people use it all the time. I just typically don't, because I'm usually in a hurry and behind on things. So you see that here. I'm just gonna hit cancel. You also see that when we remember yesterday, we did some of those annotation defaults where we labeled the bearings and distances. We did the auto annotate. If I look at my annotation defaults, I've also got some limits. Let me see, distance. All right, so it's not under my defaults. So it must be in the command itself. So if I'm under annotate and auto annotate, let's see, right for lines. So that's not use. Oh, I'm sorry. Then there it is. I finally found they moved it. This avoid label overlap. And then if I check that on and choose my overlap settings, here are these different methods. I can slide, I can offset, I can put it in a table, I can reorient, I can flip, I can move the labels, and I can choose to use any or all of those or none of them. I just swap them back and forth here. And I tell it, for instance, if I'm going to slide that label, and in this case, it's the bearings and distances. So if I'm going to slide, I tell it how many multiples of the text height do I want to slide, or offset. So offset's another, I can push it further away from the line or slide it along the line. So I'll go as much as 2 times the text height for the distance away from it. Then the maximum slide that I'm going to do is go 10 multiples of the text height. Maximum offset is 4. Okay, so it's going to do it in increments of 2 for a maximum of 10 or 4 in terms of how far to slide, how far to offset. And every time it does that adjustment to then check and see if it's overlapping something else that's already on there, again, that avoid label overlap checkbox that came from here, every time it has to do all that, it keeps checking, and it's down here on the bottom of this box. I can tell it to avoid line work conflicts. In other words, find a clear part of the drawing. Don't, slide it to keep from overlapping other labels, yes, but also slide it to not draw over top of any of the line work. So all of that kind of stuff takes some processing, but it's there if you want to use it. So I'm going to cancel all that out. Okay. Now, again, the way grip edits are going to work on this, let's say I'm going to, let's just take, say 22, 21, 20, and 19. All right, we'll take those 4. I'm going to go back to the points menu. Let's edit points. I'm going to go down here to number 19. I'm just going to type an EP there. I'll type an EP there, and I'll type an EP there for number 22. I'll go up to File, Save, and Exit. Now, it came back in here, and that's just as if I had individually double-clicked those, typed in EP and EP for my drawing description. Okay. They are now also in the coordinate file, which you can see right here, 19 through 22. Okay, so there they are. Now, so let's say that you know, I wanted the descriptions to actually be over here on the other side of the point or something, or you know, there's something that it's in the way of. Now, the way grips work. Now, let's see. Is it Ed? Are you the one using AutoCAD?
Yep.
Okay. Go ahead, if you've drawn your points, click on that point. Do you see these 4 grips show up, or only one in the middle?
I just have the one.
Okay. If you go to, I don't know if this is going to do it the way I want to keep doing the grouping in Carlson. But if you go to, if you right click options, you know what's going to be easier, I think. There's a setting, and I'm not running AutoCAD here, so I can't test it. I mean, I've got it, but it's a Mac version. I'm going to stop the screen share for just a minute. So I'll stop my share. And if you'll go, or can I request? I guess I can't. So share screen. No. Go down to the to your controls and share your screen. Oh, Joe, I see your question too, by the way. Will it see a CSV name as a coordinate, or do you need to have to convert it? You do have to import them, convert them into a coordinate file. I'll show you that in a little bit as well. All right, so great. There's your screen showing. And here's what I was talking about the other day. When you go to these options, you see those things that have the little icons? That means it stores in the drawing. So if you change, you know, oops, sorry, you're not seeing my mouse movement. Let's see, there we go. Let me do this. I'm going to request remote control, and then you have to grant that. Okay, so now you see these, like that arc and circle smoothness, that was that view res that I put up to 20,000. Looks like the default is now 1,000 in regular AutoCAD. But anything you see on any of these tabs, here's one down here, some, let's see, preferences, plots, so there, but anything that you see that has an icon beside it, that means that value gets stored in the drawing file, not in the database, not in the registry. If it doesn't have that, then when you make this change to your options in AutoCAD, it applies across the board regardless of which drawing you're using. So that's a sort of a little shorthand for you to look at. Now, here's what, it's the selection tab, I believe. Right here. See this right here on the left? If I uncheck that, I'm not going to group those objects. And so now when I select, you see I get those individual grips. Okay. And that's kind of important to do. That's a nice looking font, by the way. Now, let's see, you can stop the share. I'll stop the remote control. You can stop your share and I will go back to sharing mine. And let me get that back over where it belongs. Switch to here. So here's what I wanted to make sure you can do is that when, let's say, those labels, you know, sometimes get in the way of stuff. Well, I want those, I want to put the descriptions over here. Now remember, this came from that layout. So if I select that and get the grips to show, and then if I just hover the mouse to where it snaps down into that grip, then click with the left mouse button and slide it around, I can reposition these, okay? And I can put them wherever makes the most sense for the particular point that I'm working on. Now, I'm not, notice I've got something like this one, I've got it right over top of there because what I would typically do is turn off I would go to my freeze layer by pick and I would pick okay. What's next? Working here. Freeze layer by pick. There. Okay, so you see that looks like they were all drawn independently. Now, if I were to go back and run the command draw locate points and it redraws it, it's going to put them back where they were before. And also turn those layers back on. So if I do that, and again, now if I choose, oh, okay, so they've got that one updated too. So no, there they went. That's what I thought it was going to do. So it puts those back. If you do a grip edit to move those things around, which is perfectly legitimate, just don't grab the grip in the point where the point is located, or that will move the actual point. But there's one of those that does work. It's on the points menu. And everything in this section right here below has to do with these attributes or the labels of that point. So if you edit the point attributes, for instance, I'm going to click on that. That is that same thing that we did before, just double clicking the point. And that does more than just the attributes, that does the values as well. But it's primarily concerned with things like these descriptions and point numbers, etc. Now, the other ones is you can say move point attributes. Again, just like we did with the grips, and it says select the attributes to move. Well, I'm going to select, say, that EP, move that one here, and it wants to know a rotation. I'll keep it default. And then I'm going to move this one. So now you see it's, I have to tell it the rotation as well. So I'll move this one, and let's, put that one like so. All right, now that I could have done with those grips using the CAD tool, but because I did it with the Carlson tool, I am wondering if it's going to honor that change that I made. Now I've got points 19 through 21, so I'm going to just choose draw range, and now down on the bottom of my command line, I'll choose 19-21. Nope. Okay, so it does put them back. All right, there is an instance though. Let's say, again, you've got something that you need to move out of the way because there's line work coming in. You don't want to have that label over top of it. On the points menu, there's this really nice one that says move point attributes with a lever. Okay, you choose that command, and it's now got a series of options down here below. If I type O, or options, because that's the letter there. You can tell it to a minimum liter length scalar, in other words, plotted inches, that how far away you need to be before it draws a liter. You tell it to draw the horizontal tick or not, and what size that tick is going to be in plotted inches, because there's that word scalar. Whether or not it draws an arrowhead, yes or no, then the sizes, different layers that you can assign, and you can even rearrange the order of those attributes. Instead of point number, elevation, and description is 1, 2, 3, you can change those around. So I'm going to say, okay, I'll grab this one, and you see what it's doing is giving me a little preview of where that's going to go. Now, when you click that down, you notice because I'm using that little horizontal leader, it doesn't exactly match. Keep an eye on where that, I'll leave the cursor right here after or I'll leave the cursor right where I'm going to click it, and watch the arrow that results. See, it has a slight shift to it. That where it originally was from the point down to where my cursor was pointing right to the end of that little horizontal tick. So that's the only thing that you're going to see in terms of shift. Okay. Now, so there's one. And if I happen to move this, say, I guess I'm going to be too close. I guess my minimum distance is such that it's going to always draw that leader. Sometimes if you're too close, it won't draw those. Now, again, I can take that and then, individually move those attributes with the grips. But now here's the difference. I've got 17 through 21. Looks like that I've moved. So if I draw locate, I'll draw a range. I've got 17. I think I can do it this way. 17, 19-21. Yep, it redrew 4 points. So that honored, let's see, let's take those points. Actually, I'm going to just delete them. And then I'll draw that range of points again. And I'm going to 17, 19-21, hit enter. Okay, so that puts it back. There are a couple of instances where if you're moving, let's see, if I move, I'm going to be with leader. Do that one as well. And so there's some commands that work on these points. Let's try just a move point. So I'm going to select this point down here. Okay, so some of these things will actually, it will keep, it will honor that attribute move that you've already done. But those typically have to be commands that are, from this points menu, such that you're not doing a CAD movement of those. And you notice when I moved that point, it did not come up and say, hey, your coordinate value is different, because I'm using the Carlson command to move the point. It knows I intend to move the CRD file location, so it followed it with me here. So now here's where this might work. If I just put that, let's say I'm going to make that 842.8, I'm just going to call it 845 even in my northern. Okay, and then if I say okay, still on it. You see it push that with the leader up. Sorry. Okay, so so those will stick, and you can unset those. You can put them back to default either by redrawing the point, or you may have made some other edits or something about the symbol you don't want to change. You just run that move point attributes with leader again, and then you choose the option R to restore, and you simply pick the label that you want to restore, and it draws it over again for you, but keeps everything else that you've already set. Okay. All right, so that's a, and you have to, oops, let me see, R. So you pick the label itself. Now, here's again the option or the advantage to using, say, the Carlson draw commands, for instance, that even though you can use a CAD command to draw stuff, if you're more comfortable, you can, and you can snap to the nodes to make sure you get to the center points of those points numbers. But let's say I want to draw this edge of pavement, say 19, 20, 20, 22. All right, so I'm going to go to the draw menu. Let's draw a 2D polyline, and we'll, instead of putting that on road CL, let's put this on V-road-EOP. And I'm going to set my color, I'll leave it as yellow. I could define it by layer and all of that. That's what I normally would do. But I'm going to do it that way, and I'm going to say, okay, and now notice my prompt. Unlike the CAD system, which would simply say pick a point or type a point and using X, Y, and Z, it says pick a point or point numbers. And again, point ranges will work. So if I say 19-22, enter, there it is. Now it's still waiting for me to keep drawing some others for me, but I'm through with drawing that edge of pavement. I'll hit enter to finish it. Now I've drawn that line work. And you remember yesterday when we looked at the settings for general settings, and we had this checkbox. One of the checkboxes is link line work with points. So if that's on at the time you do this, if you go to the points menu, adjust coordinates, and move a point, let's move this point number 21 to right here. Not snap to it, that was a problem with snap. So if I pull that down to there, notice something else that's going on. First of all, you see that the line work follows the point when the point moves. If I right click, repeat, C MPNT, C colon means command, MPNT means move point. So it says select a point. Now it says elevation off. That means it's going to hold the elevation. So if I move that to somewhere else, it's not going to set it to 0. So if I move this here, and notice it says, all right, select a point. I don't have to go in here and snap to the origin of the block or snap to that end point or any of that kind of stuff. All I'm doing is picking out here on one of the labels, okay? And that, now see where my cursor is when I picked out there? It's snapped to that proper location. Okay. Now, the that linking of line works to points is not a two-way street. So if I select that line work and I get my grip to show up and I hover in the grip and I stretch that out there, notice it did not pull the point with it. But if I double click on point number 22 so that I'm editing that point, or sorry, 21, the one I'm using here, and I have to do something that's going to trigger a change to the coordinate file. I don't think I can simply say, okay, no. So I have to have actually a change. I'll put a space right in, say, okay. Now, did you notice anything that you do that actually triggers an update from the CRD file, it pulls that line work back in. So be aware of that behavior in case you ever do grip edit some lines that you created by running through, excuse me, running through points. Excuse me. Now I'll put this back, put that space out. Now, oh, I guess it did take it out for me. Okay. All right, so a couple of other commands while we're here using points. And you noticed again, like I said, I was picking these attributes and actually getting the point itself. We'll come back to that. That's called point object snapping. We'll talk about that in a minute, but we're about 15 minutes past your break. So it's about 12 minutes till 11. Let's go ahead and start back up at 11 o'clock and we'll finish up this little exercise here and then try to push ahead into the 3D stuff. And I'll show you some of the bits that I want you to look at on your own. I think we're going to just very quickly, we'll run through the point groups and what you can do with those. I think because the surveyors that use points and even you geology folks that are going to be getting a lot of your updates through point files, probably a good idea to learn about those groups as well. So whatever you have there in your drawing, let's go ahead and save the drawing. So we pick this back up when we come back. We'll reconvene at 11 o'clock. Any questions on any of this? Or is everybody comfortable with all these? I don't want to waste too much time talking about points, but is it new?
No, I'm gonna like that.
I'm sorry?
I think I'm gonna enjoy working with points a little more.
Oh yeah, good to hear. And who was it yesterday talking about? Maybe it was you, Carl, talking about doing field to finish.
Yeah, that was.
Okay.
I used Carlson for a little while at my last job, and
okay.
so that's why I know that I'm gonna enjoy working with survey points a little more.
Yeah. So I'm going to show you when we come back, before we go to lunch, I'm going to finish up a really quick little demonstration on field to finish. I won't get it. By no means will it touch everything, but I just want you to see what you can do with that. Because we're going to use it in another exercise later this afternoon that really has nothing to do with the traditional way of using field to finish. It's just a way to very quickly let us do something to keep them having to start, creating a bunch of drawn geometry from scratch. Okay, so again, we'll see back. I'm going to, I'll go ahead and stop the share so you can tell when I get back, I'll turn it back on. I will turn the recording on. Sorry about that last time. I'll tell you what I'll do, because it's really a shame. We got some good ground covered there. I will also send you links to a previous class and of course, every class is different. But if you can get a bit more information out of those as you review those later, as you're working with the software, maybe that'll be of some value. I'm just really sorry that I overlooked that when we came back, but.
Ken.
Yes.
Okay, I don't know what I pressed. I was just messing around with things earlier during lunch. Whenever I try and draw a line, it only allows me to go either horizontal or vertical.
Aha. You have locked one of the locks down at the bottom that's ortho. And if you can see on my screen, there should be an icon that looks like, a little axis with a square on it.
Oh, okay, I found it.
Double click that and that will unlock that. Okay.
Oh my gosh, awesome. Thank you.
Yep. There's another thing it occurred to me that you guys might, if you're not used to holding the shift key to get to these snaps, or coming down here and right clicking and popping this up when you need a snap, there is a snap toolbar, and I'm going to go up here and right click the gray spot, and that should be actually one of the telecad toolbars. Let me see if I look at, if I right click and choose toolbars dot 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 and then pull this list down to say iCAD, and then scroll down and I'm sorry, they call it entity snaps here, and I can turn that on, and that then brings up a toolbar that looks like this. And you can dock that anywhere you'd like. And if you want to turn on a particular snap to be full time, you just double click it. Let's say if I have a little figure here, I'll close that. And if I want to say draw another line, say from the, now remember my endpoint is currently running, but I don't have the center going. I've got these midpoints, but if I want to use that center, I can come up here with this toolbar out and just click it once, and it will find that snap, okay? And then it goes off, but if you want it to be on all the time, just double click it, and it'll go back to finding that. Now it will also find these other points that are currently active as well. So let's see, if I double click that, whoops. Oh, apparently you have to be out of the command before double clicking will make that stick. Okay. So then now, go from here to here, and if I go to it's finding the endpoints and midpoints before it gets to that. So clicking it once will make that happen. Okay, so that's the rundown on points. And remember, even though you can move these things around graphically with some grips, and if you happen to take this middle grip, that's the actual point itself, and when you move that, then that's going to make the lines move with it. It could make the it will make the edit to the coordinate file, depends on how your linking is set up. So you can do those things, but the best way of actually moving a point purposely might be to choose those commands from the points menu. Because when you do that, it's going to automatically know that you intend to do things to the coordinate file itself, and they won't get out of sync, okay? So that's a rundown on that. We will make sure that we use snapping, and we had the discussion back here. I want you to, on your own, work through this point groups exercise so you can get some further ideas. Now we're going to sort of jump into the 3D aspect of our modeling. And this is where you geologists are going to be sort of extending this knowledge into your mine planning, how you're going to develop your strata surfaces and figure out volumes in between. But what we're going to be looking at with our stuff here is using triangulation, and the mining modules, the geology module, surface mining, that sort of stuff. tends to be done with gridding instead of triangulation. And it's simply a different method. And I'll show you where those are and how you can do them. But a little bit of background to get some things started is we're going to be focused on this statement right here. And this is on page 19 of the manual. It said that every point, let's start right here with this part of it. Every point in the selected data that you wish to include in the model, those points whose elevations will indicate a point on the surface being modeled, or the strata or whatever, will form the apex of a triangular shape. Okay, and so it creates this network of triangles, and they are irregular in shape, and that's the term triangulated irregular network, or TIN. You'll hear that a lot when you're talking about a surface model. And right here is an example of how the software might or might not correctly model the ground based on these 4 points. So let's say we go out there on the ground and we shoot a point, and it's got an elevation of 110. We come down the hill, here is 100. We come back up the hill, is 110. We'll go back down the hill on this side, and it's 100. Now, if that's all the information we have are those 4 points, these points are going to become corners of triangles. Now, they're going to also go off, in these other directions and find other points around it. So it basically sits on every point, whether it's a survey point or if it is a point, just a vertex in a 3D line. Anything that has elevation on it that is either a vertex of line work or a point feature can be a candidate to model that ground. Now, if you just turn the software loose to look at points, it starts on whichever point it gets to, and I don't have any idea how it decides which ones to start with, probably the order in which they were created in the file. But it goes through those and it sits on each and every point, and it looks all around itself in a circle, and it tries to draw connecting lines to other points that it sees. Okay, so if I'm sitting here on this point, this upper left point at 100, and I'm looking around and I see this point number 110. So I draw a circle, I draw a line over to that one, that's fine. I see this 110, I draw a line over to this one, that's fine. But maybe before I got to that corner, I was down here at this corner, and I looked from 110 to 110, and I drew a line up there across there. Now, once that line is formed in the computer's memory, that's going to prevent this point 100 from looking across that line and seeing this point over here at 100. So this has already decided that this little figure is a little ridge top that runs from 110 to 110 across the top, and it falls off to the left and up to 100, and it falls off to the right and down to 100. So that's a little ridge. Okay, I follow how that part gets built. Now, the alternative to that would be this. The same figure, but maybe I started on this point instead, and I saw point number 100. So I drew this line across here, and also drew to here, and then this one drew to here, and all around itself. So now this figure is represented by, and you can see these triangular plates. They're just little pieces of surface. They're little planar segments. So this one shows a valley with an elevation of 100 across the bottom of the valley, and it climbs up on either side to 110, to the up and to the right and down and to the left, it climbs up the hill to 110. So that could be drastically different from the way the ground actually goes. What if the ground really is a ridge top across 110 and it falls off to the other side? So what we have to do is we have to know what the ground is doing. And we do that when we're out in the field surveying, and we hit this point down here, this 110. And if we go back to the case of this situation here, if that is truly the ridge top, then when we shoot that point right here and call it a ridge top, we need to know, and we need to tell the software before we process it, that this ground changes from this 110 to this 110 in a straight line across here, instead of between 100 to 100. So we do that by either surveying a bunch of points and drawing a sketch that we know, hey, this is an edge on the ground. This triangle edge becomes what's known as a break line, because it breaks the triangulation from occurring on either side of it. Any of the points on this side of this line, or none of the points on this side of the line, can see across that line to connect the points on that side. So we have to either, be very careful, and when we create our break lines in our data set, to draw those in correctly, or we use something like field to finish, and we know that, if that's the the top of a bank or something, we know all of the top of the bank lines are supposed to connect together. And that's what's called a break line. And the way to think about that in the physical sense is simply this. Here's the rule, is that if something is an edge, see, break lines are nothing more than edges in the surface. And so if it is an edge on the ground, we need to make it an edge in the modeled data. Okay, so I've seen a lot of inexperienced people who, to try to make something really precise, they'll go out there and let's say this curb figure down below, instead of shooting a few points on it, they may shoot lots and lots and lots of points, counting on the fact, relying on the possibility rather, that the points closer together are going to form triangles first. Okay, but it's really not necessary. You just need to get one point on one end and go to the point where it changes elevation or changes direction, and then shoot that point and then connect those two points together. So if you can see, if we've surveyed these points and we turned the computer loose with just the points and nothing else, then it could result in something like this. Triangles could form, say, from B to F, from C to G, from A to E. And as you can see, this would go from the edge of the pavement, rise up through the air and go to the top of the curb, and it would miss something down here because there's not a point immediately that nearby for it to connect. But it would also go from the edge of pavement here down the gutter slope to the face of curb. Now that line's correct. So is B to C. So is E to C and F to C. But G to C is not correct. Okay, so the way we keep these dashed lines from occurring is we draw the lines in between, and we use that in our data, and we let it conclude that those are break lines, and they're going to prevent points on either side of it from looking across itself and finding points on the other side. So if we then make this face of curb down here at the bottom, the flow line, if we make that into a break line, that will keep A from being able to see across it to point E or G or F or H. And same thing if we use the top of the curb as a break line, that keeps point C from looking up to the back and hitting point G, so that triangle does not form through the actual structure. And then that would work in a situation like this. It would force the triangles to form the way you're seeing them. So B would form to C, that part's correct. B would form to A, that's correct. B would not be able to see F, but B could see D, so it would draw up here. So that triangle lies on the gutter, that's on the gutter, that's on the gutter. These along this shaded surface here are all along the face of the curb, and then you see the ones across the top of the curb. So that's what we have to do. That's what we mean by establishing break lines. Okay, now, what would happen too, that even if we have some break lines, and we're going to see some examples here in a minute. Let's say we're going to try to use contours in our data as our input. So it's going to walk down those contours that every time it hits a vertex, it's going to look around itself and try to draw triangles to the other points it sees around it. And it would be, see if I've got a picture of it here, for instance. Probably best just to show you on the screen, I think. Yeah. Oh, okay. Well, here's a picture that we can look at before we get to that discussion. So here's a case. If I use these contours that somebody put in a file and gave it to me, and I said, hey, there's a good contour map, I'll just build my surface from the contours. And a lot of people do that. And it's very dangerous in this respect. When you see the shape of this feature and this feature and this feature here, now that represents the crown of the road. So, you know, so it's supposed to be the same elevation all along those points. And so if I sit on every point along this contour and look around itself, as long as I'm looking over here and I see these contours, well, those triangles are going to be fine. But what happens when I get up in here and I'm looking around myself in a circle? I get these are correct, these are correct, but I can also look over here and see these. Well, what happens there is it makes a flat triangle. So our surface in there would become flat across those triangle edges. So what you ideally need to do is go through this data and start drawing lines through all those peaks, and through all these peaks on the ditch lines and the curb lines, etc. And we'd set their elevations to the lines that they cross. And then when there's a line drawn in here at elevation, when you get to this point on this contour line, it can't look across that line and see points over here. It hits that as a break line that's already in the data. It says, hey, I can't go across, so I'm not going to form that triangle. So that flat triangle does not get formed. It always focuses down here and it can't go across. So that's the basic rule of that kind of processing. Now, how do we make that work? Let's see what we have. So let's come back to our Carlson. I'm going to actually close that file. And I'm going to open a file, make sure I'm in my data sets. And I'm going to open this sample from T3global.dwg. Now, again, this is all very legitimate data. It came from a photogrammetric project. And I'll show you some of the tools that we typically will use to, to look at files that we get from other people to evaluate, were they done correctly? How does everything work? And does it work for our needs? And you can also put yourself in the position of, if you're out there on the ground, what are some of the things that you need to collect on the ground to make sure that the data is modeled correctly? And those are the breakpoints. Now, these are, because they're white, what what I want to do is I want to select that. That's on a layer called gtopo.bkln. I'm going to change that color just so you can see it better. You don't really necessarily need to, but I'll do it here so we can see it. I'm going to make it sort of this vibrant orange. All right, so there's all of our three-dimensional information. And if we, I'm going to select one, then select similar. And I'm going to view it in the 3D viewer. Now we'll get into how this viewer works and we'll see some tools later. But if you look at this as it's positioned around, you can see that it very clearly is drawn at differing elevations. And these are all of the edges that the guys running the equipment in the photogrammetry company were able to see in that stereo model when they started to trace out these lines. And so they just go through here and make a bunch of these edges. Every time they see an edge along something, like there's some down the crown of the road, there's some down the sides of the road, some at the, down here, say the curb. So they put those lines down there and set them right on the same elevation as the ground. You know, their equipment is actually helping them to place that and put those into play. And then once they get all of that stuff done, they also do things. You see all these little pink dots in between. Those are our individual points. And if I, well, let's just do all of it. You can see a second. Then that is basically, let me turn off for a minute. So there's some spot elevations and such in there, but so you can see that now, even up here where they only got the top of the bank, because this wasn't really all that well defined in terms of edges, but they still got a bunch of points in there. So in that situation, there was nothing that really stood out as an edge until they got over here to the edge of the hill, and it sort of, you know, went off on the sides of the hill feature. Same thing around these edges too. So they sort of, you know, filled in the open spaces with some, you know, just some random ground shots. So that part's fine too, because we can't really distinguish where there's a specific edge. But then this is all the information that they captured vertically, and they used that to come through here and generate these contour maps. And I'll turn off, I'm going to freeze by pick, and I'm going to pick that set of 3D lines. And this is the actual file that they delivered. And it's absolutely accurate. Here's the contour line. It comes down here, hits the curb face, runs up the face of that curb to the back of the curb. That's a triangular curb, you know, a wedge curb, so it doesn't actually have a, you know, a flat top. And then, you know, follows around, goes across a sidewalk that has a bit of a slant to it through there. So, you know, there's, you know, that this is the resulting model. Once they built the model, which is continuous in here, they then had the computer draw the contour lines along those lines of constant elevation. So that's really the process. And we need to start to think about contours as really simply being the resulting output of a continuous model, a model that has all these little triangles in it as it formed, and then it looks at each one of those triangles and decides where the line of elevation is, and it draws those things around it. You can see this contour here. It goes up, walks up to the top of the curb here, comes across the ground, hits the top and comes back down the face and then comes back out the other side. So this stuff is really very nicely modeled. But if I were to isolate just these contour lines instead, and keep your eye on this one right here. And if all I did was to create my surface using contours, when I'm walking along this contour line, I hit all these little vertex points. When I sit here and I look around myself, I'm going to look over here and I'm going to see this point. I'm going to say, okay, I'm going to form a triangle there. And that makes that triangle the very same elevation. Whereas I know that in here, that ground is either higher or lower than it is on either side of it because the contour line doesn't go through it. So unless I put that line from here down through here, I'm not going to be able to see that. Or in the case of that's a curb structure, those are the lines that interrupt that. So if I turn those layers back on, I see that this particular 3D line, well, that's the 2D line part of it. But I would see the bright line part. Back on. So I can see that this 3D line is going to prevent points on this contour from looking across it and seeing points along the contour line itself. Okay. So that's the concept of if it's an edge, and right there, the face of the curve and the top of the curve, those are going to be edges. If it's an edge in the actual real world, we need to define that edge before we build the model. And we need to be very wary of when we get a file, go back to freeze that. When we get a file like this, we may look at all that stuff and say, look at 3D again, we look at that and we say, oh, wow, you know, that's really nicely defined, nice little contour map. I'm just going to build a surface using those lines. Well, the problem is when you get structures like this over here, you're going to flatten out those little valleys and ridges because the points along this contour line, for instance, are going to be able to look across and see the points along the other part of it and call those the same elevation. So you would have to, if you took this data and that's all the data you had, you should then draw lines, you know, connecting the peaks of all of these 3D or all of these contour lines. And you would set those lines to those elevations and do that everywhere there's some significant peaks so that you can more readily define that surface. All right, so that's what we would typically do is either go through the effort of drawing those lines, and here they're already, some of them already drawn in, like there's the center line, and here's a couple of, you know, fold lines in the pavement. Over here, some the curb lines, but now these are just 2D, so I need to elevate those and make them the same elevation as these contour lines when they cross them. Okay, so that's another technique that we can use, but the serious thing to keep in mind with all that is if all that you have been given are a bunch of contours, then sometimes that's what you have to build your surface out of, but recognize the fact that it's going to be inherently inaccurate, okay, because of those flattened triangles that you're going to get into. All right, there are some tools and techniques other than just drawing break lines that you can use to help that situation, but it's far from perfect. The ideal situation is if you ever get files in from somebody else, first of all, the most ideal situation is ask them if they can send you the surface data file directly as part of their deliverable. And if they're not using Carlson, you need to get it in a particular form, and that's called land XML. And you can import a land XML file. You can also export a land XML file to give it to somebody else. That's a universally understood format that all these other software packages, excuse me, also recognize. And they'll bring in all of those triangles as part of that data and use that to build the surface. So then you can create the contours from those triangles. And those contours then should exactly match where these triangles are as well. Okay. So just as a quick indication of that process, you have your file open up here. It would look like this. Let's set this up and we're going to learn how to use the 3D viewer and see what happens when we model the surface with a couple of different ways. So if we, first of all, I want to freeze, now mine are orange, yours may still be white. I want to freeze that break line layer. So I'm going to go to my view menu and choose freeze by pick, or I'm going to choose that from the toolbar, which is this icon right here, freeze layer by pick. I click that and I just click on one of those orange lines and it goes away. Now I'm still in the command, so I'm going to go over here and I'm going to pick also on one of these pink dots, those points. I'm going to turn those off as well. And then I'm going to hit enter to finish my command. I've now turned it off. And this is a contour map that is typical of what we would normally get as a deliverable, say from an outside survey firm, unless we ask for the additional data. And if that's the case, and if we have to use that to build an existing ground surface to do some work with, then we're going to be starting with a lot less data and it's going to be less accurate. And we'll see that in this exercise. So how do you build a surface? How do you build that resulting network of either adjacent edge triangles or a grid file for you geologists? And that's going to be done from the surface menu. And we have a section up here at the top dealing with triangulation, which is what we do mostly up on the top of the ground with surveying and civil engineering work. And then there's this section down below here that has a command that works with a 3D grid file. Notice the icon is a series of regularly spaced rectangular grids. Now, what that is for, and the reason they use that for mining, is that it creates a structure that's very regular. It's evenly sized. The interval's all the same. But what it does underneath or behind the scenes, it's actually going to build all those triangles for us. And then when we go to make this grid surface, it's going to sample all those triangles at those regularly spaced grid intersections, read what the elevation is from the triangles, and then set the elevations of those grid points accordingly. And then it throws away the triangulation. So what happens if you are working on a grid and that grid happens to sort of span across a very finely defined feature like this edge of pavement or this ditch edge, whatever that is? If one of your grid points is over here and the other grid point's over here, then when it makes that grid, it reads the triangles here very accurately, nicely done. Comes over here to this one, reads the triangles accurately, very nicely done, but it connects a straight line between them. So it assumes the elevation changes linearly between those 2 points, and it doesn't. It comes down the hill and it comes back up the hill. to get down to the ditch bottom and back up to the top. And that's what our triangles will give us, a little better accuracy there. But the grid system is much faster when it does calculations. Now, that being the case, let's do this off to the side, or you can just watch what I'm doing. I'm going to draw a little representation as if this is a profile cut through the ground surface, okay? Pretend I'm looking at it edge on. And say that might be my existing ground. And then I have another surface. Maybe this is a, designed some pavement, and maybe it goes from here down to here, and then maybe somewhere else. So that might be my surface. So here's why grid files work with mind modeling, for instance, is that if I'm going to calculate the difference between these two surfaces, I'm going to look at it in a series of slices, and I'm going to say, well, what's the area of this difference in here? I'll calculate that. That's how much I have to cut that existing surface to get to my design. Likewise, in here, this area is how much I have to fill on top of that existing surface to get to my design. It takes that in a series of slices all across the site, adds those all together and multiplies them, gets an average, and it comes up with a number. Now, if our existing ground, let's say we go down this ditch line and we hit a bunch of say a bunch of let me change this orientation a little bit and make my existing ground a little bit like this instead. All right, so instead of that, maybe we had a situation where our existing ground looked like this, because we hit those flat spots. So I went up to there, and then I came up to here, and I came across flat. Actually, let's do it like that, and then say up here, it came across, sort of, came flat again, and then it came up here. So this might be the incorrectly modeled surface because I'm hitting those flat spots going down these ditches. So I'm not really getting that nice smooth line when I walk down that ditch. I'm getting something that looks like this jagged stair steps. Now here's why it works when we're doing geologic modeling, which is dealing mostly with the differences between surfaces, because right in here, this triangle here, this is a case where our modeled surface is lower than the actual surface. So that makes us compute in this area too much fill to get up here, okay? But if we come up here, my modeled surface, which is green, compared to the yellow surface, which is the more accurate one, the difference between, this green and the red up here is a little bit less than it should be. It should come all the way down to the yellow, but it's a little bit less. It's a little bit more here, less here, more here, less here. So the reason this works for volumetric analysis is that on average, across an entire project, the areas that are under will tend to balance out with the areas that are over. So if I had these surfaces to compare with, you would run a volume calculation and find out that the volumes tend to be pretty close to the same number. But the danger lies in, if I need to use that modeled surface instead of this real surface to then define where I'm going to put a catch basin, for instance. If I'm using this and I decide to put my catch basin right in here along this point, it's going to be too high up in the air. All right, so it all depends on what you're trying to do, what you're trying to model as to which modeling method that you use. Now, I will say for the surveyors, engineers, pure things up on the top of the ground, you're going to 99.9% of the time, you want to use triangulation. But for those larger geologic models, because you're dealing with a whole stack of, anywhere from 8 to 10 to 20 different strata under the ground, you don't want to have to deal with 20 different triangulation files and try to do those calculations, because they take a little bit longer than those grids. If you use the grids to be regularly spaced, the same position through all of the different strata, then we don't care about the fact that it's going to jump across that little ditch line here, because there's going to be another place where it goes up a little too high across the ditch line. And on average, they're going to balance themselves out. So that's the difference. And again, we'll focus on the triangulation here, but if we do a surface from, I'll show you how the command starts with the grid file. It's going to ask us for a new one. It offers the same name as the drawing. I'm just going to call it jump. And so save. So here's what you can do, and it's going to read, different. So you can read an actual triangulated surface, or you can use screen entities. And then you choose the method that you're going to use, which is by default, it's also going to use triangulation. It's going to build the triangles, sample the triangles. Down here, it's going to build a grid of 100 feet by 100 feet, or whatever numbers you put in. Or you could say, I want, 200 cells in the X direction and 200 in the Y direction, or whatever values that you choose. So then when it comes up here and models the surface with these different methods, it samples with this grid resolution, reads what it modeled, sets the elevations to the grids, and then throws all this stuff away because it's finished with it. And it's just left with that much more efficient file. Okay, so now also in our modeling, because of the nature of geologic modeling, you have, strata will behave with certain predicted modeling techniques or certain physical characteristics. Like if you drill a drill hole over here and you do a drill hole over here and you read those different elevations, well then based on other drill hole data that you find around the area, it looks at the same strata. Say it's the top of a coal seam, but it knows that if it's a certain depth here and it's a less depth here, and then it's nothing over here, somewhere it peters out and goes to nothing. And that's what a lot of these things like inverse distancing, Kriging, polynomial least squares, ABOS, Voronoi, nearest neighbor methodologies. Those are things that help the algorithm determine where those strata might do what's called pinch out in between the actual sample points that we have. So we just don't have any way of modeling that layer of material under the ground very tightly. We can only do it as closely as we sink our boreholes and find out what those depths are. So that's another reason to use that gridding, is it has those additional methods of computation. Now, all of that stuff you can just flush out your memory banks if you don't need to use that directly in terms of surveying type modeling. But I wanted to give the geologists in the class a little bit of background about where that is. And when you are in the geology module, which I don't think mine will, yeah, see, it tells me it's not installed. It is installed, it just doesn't have the license to run it. So, but when you actually are in that set of commands and menus, under the surface, you got a lot more tools and you got those grid file constructions. So that's going to be where you're headed when you're doing your mind planning, and you're going to do all that with grid files. But for now, the concept is the same. We're going to essentially look at data that has points in it, either line work, or in the case of those individual points out there, just straight points, and we're going to start to construct some triangles. So if this is all we have, our contour map, how do we build a surface from that? And that is on the surface menu, and it's called triangulate and contour. And it's a combination command. Really, the only thing you need to do with it is to triangulate the data that's built the triangles, because you can always go to this command and contour from that resulting file. But this command is a combination that lets you do the contouring as part of that step. So let's go ahead and choose that and see what we've got to set up. Now notice again, down below, you've got load settings and save settings. So if you set something up with a bunch of layer names and such that you want to use, save them and load them up later. We have across the top here 4 tabs: triangulate, contour, labels, and selection. Let's look at the selection tab first and make sure that these 2 top boxes are unchecked. Otherwise, you could restrict the data that it's going to read. Let's say you don't want to read any 2D polylines. You would uncheck that, you see. So that's a way of filtering your data. But for right now, unless you specifically want to, make sure that's clear. And it's always a good thing, at least the first time you run this in a session, to look at that tab and make sure it's not filtered unless you want it to be. And then next we have the process. This is triangulate. These 2 tabs are the contour part. So triangulate and contour. So let's look at triangulate. When you build triangles from this data, you can tell it to draw those resulting triangle lines, draw the triangulation faces, which creates 3D face data, which if you change your viewpoint, instead of wireframe, you were in realistic mode, you would see those as solid triangles. You can draw the slope arrows, so it figures out how water would flow across those triangles and it draws those slopes. But you can do all that stuff after the fact as well. The key is to check on this right triangulation file. So if you check that on, then hit the select button. Make sure you're in your working folder, and let's call this file EG-1. That's going to be my existing ground first job, first pass. Now, you should see that file name here that's checked on. I've got another checkbox that says use inclusion and exclusion areas, and those are just closed polylines that say, an inclusion area says, even if you select data outside of it, I only want to look at the data that's inside this bounding closed polyline. We're going to leave that unchecked for right now. And we're going to go to this next one, shrink wrap perimeter reduction, and we're going to pull that down and choose none. Okay. Now I'll show you the effects that these have in just a second. Now the next checkbox is pretty nicely important, because if you see these blue lines and these pink lines, those are those 2D lines that exactly match those orange 3D lines that we turned off, but they're all set down at 0 elevation, just so in case we want to give it a line style or something, we can do that. It's a 2D line. But I don't want to read those points along there that have 0 elevation and make that part of my data set. So instead of having to go through and select only the things that have elevation, I'm just going to check that box and say ignore zeros. Okay. Now, what happens if those are 2D lines, but they're accidentally sitting on an elevation of like, negative 10,000 feet? Well, you're going to see that even with this switch on, you because you're going to see some really bad things happen in your surface. I'll show you some of those techniques to look at to evaluate your data. So we have that ignore zeros. I'm going to uncheck densify break lines for now. And I'm going to leave this interior and exterior triangle length edges set to 2000. I'll leave everything else unchecked on the rest of that page. I'm going to go up to the contour tab next. I'm going to check on to draw the contours. I want to draw my contours by interval. Otherwise, I could choose to contour a specific elevation, but I'm going to leave this as contour by interval. I'm going to give it a layer name here. I'm going to call it EG-minor for my contour layers. And then I'm going to check on to draw the index contours, and I'm going to put them on a separate layer, EG-MAJR. I set my contour interval to 1, which should automatically set that up to 5, but some combination 2, 10, 5, 25. So there's one of them that doesn't actually trigger the change. So just make sure they're a multiple of 5 away. And everything else I'm going to leave unchecked. I'm also going to leave unchecked, or I'm going to set to have no smoothing. Otherwise, you can, once it reads and starts to create the contours, you can control how much smoothing those lines go through. Now be careful of that, because all that's doing is editing the drawn polyline of the contour. It's not changing the surface at all. And you could get contour lines that cross each other, or they could just be terribly non-representative of what the data actually shows. So I like to leave that turned off. And if we need to add data to make our contours look smoother, then that's what I would typically do. Okay. So draw contours is on, contour by interval is checked. I've got my layer names. I've got my intervals. And I have no smoothing. Everything else is left off. I go to my labels tab next. So I want to label the contours. And I'm going to put this on a layer called EG-LABL. I'll use this standard text style for my label style. I'll also come down here and put this as the same layer name for index contour layers. Okay, so now this up here where it says label contours, that's going to label everything unless I come down here and check on to label the index contours only. That's what I want to do. So I'll put that on. I'll align the text with the contours. I'll draw the text on the real Z axis. So put the text at elevation. And I'm going to come over here on the right-hand half of that, and I'm going to check on to hide the drawing under the labels. A couple things up here above. I want to make sure that I choose all for my integers. I set my text size to whatever you wanted. I've got mine to 800ths. How many decimal places? I'm going to leave that sitting at 0. The minimum length doesn't really matter, but if your contour line is not as long as that minimum length, it will not be labeled. And this break buffer offset, that is controlling if I were to break the contours at the label with this first checkbox, that controls how big of a gap it cuts into the contour line. But now the reason I'm not checking that on, but I am checking on to hide the drawing under the labels, is I want to be able to reposition those labels along the contour line. And if I've broken that line, it won't let me move it. There's nothing to move it along. So if I don't break it, but I hide it, it has the appearance of being broken. And if I reposition it, it will appear to be broken in the new place I place it down. All right. So these are my check boxes. Index only, align with contours, draw on the real Z axis, and hide the drawing under the labels. You can now choose how often to do it. You can choose none on the interiors, 1 per contour, 2, 3, or 4, or you can go a particular distance. Let's put this up to say every 500 feet. So if a contour line is, 1,500 feet long, it might throw 3 labels along its length. That should be all we need. Let's say okay, and let's read our prompts carefully and react accordingly. So it's prompting me to select entities, but I read the line above it and see what it's asking me to select. It says select the points and the break lines to triangulate. Well, I turned my break lines off, but a contour line is also a break line. Any line with some elevation on it is a break line by definition. So I'm just going to either draw a window around it, or I'm going to type the word ALL, and it selects everything. And remember, we said ignore 0, so that gets ignored. I hit enter, and off it runs and generates a surface and draws contours. Now, here's what has happened. I've got contours way out in here where I didn't have any contours before. Okay. I've got contours that on first glance look, like they match the other contours. But if you look in here, especially those areas where I told you about, you're going to see there's the original contour, but here's my contour. See, it thinks it's flat across there. Same thing with this one. My surface thinks it's flat across there. The original contour comes way up here. So there's a good place of error. Look over here in this area. I've got all kinds of contours out here that just simply weren't drawn down in the original data. And that's because they trimmed those out, and they don't do this anyway. This is a loading dock right in here, but it doesn't look like what the contours are showing us that it looks like. But a lot of people will model based on contours. They'll run that process that we just did, and they'll say, hey, I didn't get any errors, therefore it must be right. And they'll proceed on down the road with some seriously incorrect data. And we'll take a look at that data here in just a minute. Now, let's go up to the edit menu and choose erase by layer. And I'm going to select the layers from the screen, and I'm going to zoom in down here, and I'm going to find one of my labels. I'll select that. I'll select one of my red contour lines and one of my white contour lines. And that now identifies those 3 layers that all start with EG. I leave all checked on, and I'm going to hit OK to turn them back off. So you saw in here we had contours that we didn't really need to have, and here's why. When I selected these lines over here on this edge, let's say, I'll look at all of these, and I also have this and this, that. So what happens if I don't tell it to don't look across there? When I'm sitting on this point here on this contour line, I'm looking all around myself to try to find other points to connect to. And I see these, and I get little triangles in here, and those are okay because it goes from there down to there, pretty straight line. But it does not go from here all the way across up here and start building triangles in here. But that's exactly what it did, because I didn't put any kind of a boundary to act as a break line to keep that from happening. Okay. So if I look at my surface menu, and I want to draw surface. So about halfway down, I'm going to draw surface. I'm going to draw the triangle so you can see them. I'm going to read my surface file. I'll say open. I'm going to just draw them as lines. I'll uncheck the use inclusion. I will turn on use or erase previous. So if I do this several times, it's going to automatically erase them. I'm going to take the default layer of T-Mesh. I'm going to say, okay. It's going to read the surface and it's going to draw all the triangles that it created. Okay. So that's what the surface really looks like based on the data I gave it. And all of these points along those original contours, because there was nothing bounding out here, it was able to look around itself and it said, oh, hey, I see that point way over here. And so it starts building those triangles. Okay. Same thing down here. I've got these long, skinny triangles that formed that really aren't there. Okay, but it doesn't know any better because that's what it created. And if we look at those as, I'm going to pop this into the viewer real quick just to show you what the mess looks like. Then you can see, it does form some of them correctly, but I've got these in here that are just not valid. And then I've got this mess going down the roadway. You see how jumbled they are right in here. You can see those ziggy-zaggy looking signs. Those are those flat areas going down that edge of the road. Okay. So we are going to, let's clear that out. We're going to do another erase by layer. And this time I'm going to clear that list. I'm going to select from screen. I'm just going to pick one of those pink triangles on layer T-Mesh and say, okay. And after it thinks about it a while, it's going to erase them. There we go. All right. So some of the automatic ways that we can do that. First of all, if you know what your data looks like, you could simply draw a line or a polyline. Rather, it has to be a closed polyline. Let's see. That I don't want to. I'll come down to like this. I'm just sort of outlining the shape of my data here. And then I'll type C to close. So it's mathematically closed. I'm a little bit outside of my edge. I might then decide I want to take this and do a standard offset. And I'm going to go down here. My prompt says enter for through points or give it a distance. So I can type T for that through. And the through point is going to be, I'm going to come inside here a little ways, like say right in here. And so it takes that line and brings it inside a little bit. Now, the reason I did that, and I'll erase my original, is so when I go back to build this surface now, I'll just simply run that command again, triangulate and contour on my surface menu. This time I'm going to check on to, and it's on my triangulate tab, I'm going to check on to use inclusion and exclusion areas. And I'll say, okay, oops, I'm going to say no to that. It wants to write the triangulation file. It's going to write over top of the original. I'm going to change to a new file now. And I'm going to change that name from EG1 to EG2. Save that. I'll say, okay, and now read the prompts. And it says, again, select entities. Well, don't get excited and just start typing all or grab everything. Read what it's asking you to select. It says select the inclusion polylines. It could be more than one, or press enter for none. So I'm going to select that line that I just drew. That's my inclusion. I'll hit enter because I'm finished selecting inclusion polylines. And now it still says select entities, but read the line above, select any exclusions. Now I could go through and find all the building outlines and call those exclusions. I'm not going to bother with that for right now. It says enter for none, so I just hit enter. And now it comes back, it still says select entities, and now it says select points of break lines, triangulate. At this point now I can say ALL, hit enter. Off it goes, and notice that the triangles only go out to the edges of that included boundary. Okay, so that's one way that you can restrict your data. Let's say you've got 20,000 acres over here, but you're only working in 1,500 acres in this one corner. Well, you can just draw that boundary around your site, and you could select all that data. It will look at it and throw away anything that's on the outside of it. And it throws it away in memory. It doesn't erase it from the drawing. Okay, so that original data is always still there. You can see those green contours sticking underneath it. All right, so that's one way that we can improve that, is by simply drawing a boundary and using it. Now I have it highlighted. I'm going to delete it and then show you another technique of doing that. I'm going to go back to erase by layer, and this time I'm going to select from the screen, and again I'll jump down here and select one of my labels, select my red line and one of my white lines. I hit enter and hit OK. So I've now cleared those out. Now, another way to have the computer decide to draw that boundary for us is what's called a shrink wrap boundary. And you can do that on the draw menu and choose shrink wrap entities. And if we do that, you can give it a layer name, and we're going to choose across gaps, and that's going to let it jump across the ends of these contour lines as it's considering the data. If we said bounded line work only, when it gets to this gap, it goes all the way inside until it hits another edge and then walks back out. So you don't want to do that in this case, but it's useful for some other uses. All right, and then you can give it a maximum gap if you want, and a perimeter reduction. Now that has to do with how it gets rid of the data, because the way it creates this is it triangulates the same way we did the first time with nothing, and it's got all those long skinny triangles. Okay, and then it does all this in memory. And then this perimeter reduction, it means how harshly do you want to eliminate or reduce those perimeter triangles. If you say none, then you would get this. I'm going to go ahead and say none. I'm going to make it a 2D polyline, and we'll say okay. It says select the points in line work to shrink wrap. I'll say all, and you're going to see what happens with that. So there's no reduction. So this was as if it had created those original triangles, just like we did, and then it draws a boundary around all of those triangles, including the ones that are in this area here too. So if I use that as my boundary, I would see no difference. Now I could simply, come in here and start, making edits to that, because again, it's nothing more than just, it's just a polyline. There's nothing special about it, okay? So I'll erase that one, and I'll show you the difference in the settings. Let's go back to draw. Shrink wrap entities. I'll leave everything here except instead of none, I'm going to go all the way up to high. And I'm going to say okay. I'll select the data, and you see that this looks at everything, and around here that looked pretty good. See, it reduced those pretty well. But now what happened here? And I can tell you what happened there is that there is a little stray point over here on a layer called V site STRC, probably for structure. So that's, I think, just a stray piece of data. and I'm just going to draw a little window around it so that it's selected, and I'm going to erase it. I'll select that polyline, erase that one, and I'm going to do that again so that I get that thing out of the way. I'll shrink wrap, leave everything like we had it, say okay, select all my data, hit enter. And now you see, like along here, it's nice and smooth, but when you get into areas like this, you see, and the gap was so big across here that it jumped in and started walking around it. Now, you could go through here and you could edit by, removing these vertices. You could even do something like this. Let's draw another 2D polyline. And I'm going to say okay, and I'm just going to start out here in space, and then I'm going to say F to follow. Select the polyline I want to follow. Well, I want to follow that polyline. Okay, well, where do I want? I want to start following it. It says pick the first follow point. I'm going to pick right here. And it asks me, do you want to interpolate those elevations? Well, I'm going to say no, because I'm just doing a 2D line. And now it wants to know the last point along that line that I want to follow, or a distance. Well, I'm going to come over here and I'm going to say, when you get to this point, you can quit following it. Okay. And so now look what it's asking me. It says, is this correct? Yes or no. And that's because it's a closed polyline. And when I start here and stop here, it doesn't know if I want to go along this route or go around to the outside. Now, it normally would light itself up. I was zoomed in too tight. So I'm going to say no. And it says, okay, is this correct? Actually, it's not. It's not highlighting here. I think I probably need to restart. I see I've got an error in function. Let's see if it does it the right way. Yes, it did. So it started out here in space, went here, and it followed all the way around till it gets to this point. And then I'm going to go from there to say, just right over here. Well, let's just put it here in the middle. And then I will close. And after it runs around its length, it's going to calculate and come up to close the polyline. At which point I'm going to just grip edit it, hover of the grip, remove that vertex. And now there's a nice straight thing. I've printed out this original like that. There's my original one. I could then just simply throw that away, and I could use that as my resulting boundary. Okay. So now that's a lot of work, even still, to do all that kind of editing. So what you might do is you could try that shrink wrap command with different settings. And what I have found is a pretty good setting. It depends on how jagged it looks. If you tone this down a little bit, again, if you say none, you get all the way, you get those included triangles. If I say low and then go back and grab my data, you see that it's a lot smoother through here, but I may need to, tighten this up a little bit by adding some additional points in there. And you can just, oops, not move it, but add, you can just sort of do this. And what I'm doing to get those menus, I'm just hovering the mouse until that pops up, okay? So I'll fine tune that a little bit. And I might go over here and say in this area, I'm going to actually just get rid of these because it jumped out here and found that data and really those are building corners. They're not really part of my topography from that, okay? So I would do that, maybe change the same thing down here with this building data. So, you know, get rid of these vertices so that it goes from here straight across to here. Okay, I could also do real quick edit. I could come here to that endpoint, go across to that endpoint, and come out here. Now I've got a crossing polyline, a different polyline. I've got a command under edit that says to break by crossing polyline. I choose that, it says select the clip edge. Well, there's my clip edge. Okay, and you just pick it. It's only one, so it doesn't, you don't hit enter after that one. It says now select the polylines and the lines to be clipped. Well, I'm going to clip that one right there. And it has clipped it in the sense that it's made a polyline here and it's made this polyline here. So I can now just select this and this, delete those two items, and select this polyline and make sure I go back to my properties now and set it to closed, because it has to be closed when I use that as a boundary. Okay, so that's a, you know, that's a pretty nice feature, and that was with a low reduction. I had to make a couple of edits. I could use that, okay, but one last trip through the process, I'll show you that if you go to the surface menu and choose triangulate and contour, and this time we will let it right over top of that file, but I'm going to uncheck use the inclusion exclusion areas, and notice what pops up: shrink wrap perimeter reduction, the same thing we just did manually. So again, I pull down none, low, medium, or high. I'll set it to low. I click my setup button and decide if I want to draw it or not. I will draw it just so I can see that it did, that it behaved correctly. I will make it 2D, and I will put that on. I think it was surf. Yeah, surf BDY right there it is. And I'll say okay. And I'll say okay. And now it asked me, it said okay to overwrite the file. Yes, it is. And I read my prompt, read the line above it, select the points and break lines to triangulate. This time it's not asking me to show it the boundary. I haven't created it yet. So I just select this. In fact, I'm going to bring my window in a little bit so I clip off those buildings and it doesn't select the buildings. And I say okay. And it will draw the triangles, or I'm sorry, draw the contours, but it also draws this boundary that was just like I had done the shrink wrap boundary. And so now it trims off my contours, and also it trims off the definition of the surface to be only that with inside that bounding line, that bounding polyline. And you can see that a little bit better to view it with here. That's what it looks like. Okay, so it can automatically do what you're trying to do. All right, and you can either keep it or you toss it away if you're done with it. It doesn't matter. All right, so now we have two surfaces that we could look at, and really the only difference in the two is that there's information in the first one over here, and we've now eliminated that information in the second surface. Now, let's, instead of using contours, I'll go ahead and just select it and delete it. I will choose erase by layers. I'm going to leave these layers up here so I don't have to pick them again. I'm just going to hit OK. And so now, instead of using those contour lines, I'm going to turn all of my layers back on. I'm going to freeze by pick, and I'm going to pick one of the existing contours, one of those existing major contours. I'll zoom back out, and I've got some labels. I don't need those. And then I've got these sort of broken contours. They're in a separate layer. So I'll pick one of the yellow ones, one of the green ones. That's because those were contoured in that obscured area, and they don't guarantee their placement within that. Okay, so now I'm left with the original data that they used to build the surface, build their surface from. And so now with that, if you go back to surface, triangulate and contour, again, just leave everything except I'm going to change the file name now to call this one EG3. I'll hit save. And I'll choose OK. I'll read my prompt again. I'm having it draw the shrink wrap. So I'll select all my data. And off it goes. Now you're going to see an error come up, because there actually is a couple of places, like right in here, there's a crossing break line. I select it. I see it's 0.321 difference in elevation. I can zoom to and zoom in. And this particular structure, these two lines right here, are supposed to be the top and bottom edges of the head wall, and they've got them crossed. Okay. Now, you would simply, if you had a situation like that, you would just simply come in here and, you know, make these changes so that they no longer cross, and then you would go back and read. Okay, so that would be off. So now that would then eliminate that one. There's these other places too, some vertical edges, you know, where when they were compiling the data, they sort of missed the mark on those places. So you would clean that stuff up, or you would just, you know, simply ignore it. And if I go back now, I'm going to erase by layer again. Just hit OK to clean those off. And I'll take this one off too. Surface, triangulate, and contour, and I'll leave that file name the same. You'll notice also, so what was I going to point out? So I'll say, okay, yes, overwrite the file, and I'll pick this data. Now, I'm still going to get those vertical edge errors, but I eliminated that first set of crossing break lines. Here's another one. And I would simply, you know, zoom in here tight enough to see that it actually does cross. I would just break that off a little bit. All right, so you can do all that, but I'm going to just, you know, they're less than a tenth in either case. And I'm just going to hit exit and let the file be what it is. Okay. Now here's the case where the bounding polyline that it found, you know, goes outside of this area a little bit. Could have made some edits to that and rerun it again, but there's no need to be, you know, hyper vigilant about all that stuff. That's just a means of trimming off your contour lines. You can also go back later and just, you know, do the trim manually. Put that up so you can see it. And so there now is my resulting surface. You see this is a lot rougher along this edge because I wasn't going along the ends of their trimmed contours. I was going along the actual edges of those 3D break lines that they had drawn for me. Okay, so this is actually a lot tighter. Now look at the contours. And if I turn their contours back on with this freeze-thaw all layers, and now I'm going to freeze by pick, and I'm going to turn off that set of yellow lines. Now look in here. See, this green contour was their original one. The white one is mine. See how it's now follows it almost exactly. There's that green one is their original. The red one is mine. So that lets me know that that surface is a lot better defined, right? And here's a little place where it's, there's probably some reason, either they adjusted the contour lines or their algorithm is just slightly different in the way it interpreted that. But that's close enough to being the same. I can live with that. If I saw some major errors, I would fix them. I look over here where I used to have all those sort of ski ramp contour lines, and you see they no longer go out there. They're constrained by that break line that was the bottom of that loading dock, and now that's a nice smooth feature in my surface. All right, so let's take a look at these things. Oh, I know what I was going to show you. When I keep going back and forth to build this surface, I'm always hitting this erase by layer so that I can erase these contours and labels. You can also set that up inside the triangulate and contour command on that triangulate tab, where it says right here, erase previous contour entities. I've got it turned off, but if you have it set to these, then let's say you use one, you got a set of drawn contours, you like them. And then even if you change, you're doing another surface, maybe a design parking lot, and if you go over here on your labels, and even if you change these layer names, it knows that those original contours were created as part of this command. And so if this is set to all contour entities, it's going to erase those again for you. But it's not a problem because you can always draw the contours later after you get the file. Okay, so now we've got a surface. We have three surfaces. Let's take a look at what we have. Let's go to the view menu, the 3D view. And we have a surface file viewer. Now the difference between these two views, there's a drawing viewer and a surface file viewer. The drawing viewer is going to prompt you to select things that are drawn in the drawing. That's what we've been looking at so far. But a surface file viewer lets you pick a surface. And you can see when I select this, you see the boundary that shows you what those things look like. So let's look first at our EG1. We hit open. It's going to load up in this 3D viewer. Now yours may look like this, okay, when it comes in. That's no problem. This window is resizable. I just double click the top stripe and it maximizes. And right now, I see all the triangulation lines that formed. And that's because on my settings tab, I show, I'm going to turn off my display contours for right now. So those red lines are going to go away. But I see the triangles and they look like triangles. And that's what they are. So if I go to my view control tab, there's an icon right here that toggles the shading of those surfaces. So if I toggle that, see what it's doing is turning it on and off. So now I see all the triangles, but they're colored in. And if I want to see also the triangle edges, I can go to my settings tab and turn on display triangle edges. And this set colors lets you set those particular colors. And I'll turn those back off. I may want to look at my contours. Now, notice here, I'm only using a 5-foot contour interval. If I want to match what the original had, I could change that interval down to 1. And the point of all this is to illustrate that I'm going to make it 0.5, half a foot. So the point of this is that is to realize that these contour lines are just an interpretation of those triangles. That's all in the world contours are. They're not really surface data. They're the results of surface data. All right, so let's put this back to one so we can match it. And again, now you see these wonky looking flat edges over here. I see this wonky looking thing over here. And now let's learn how to move this thing around in 3D. So back to the view tab. I have a number of options I can do. Color by elevation. Right now I could say, surface only. I turn that on and I see a range of colors from this low down here at 1282 up to 1339. I can't really control that, the interval, but I can control the colors. I would do that in that set colors button. And you can see now that the high spots are red, the low spots are blue, and the medium spots are green. Now, what usually happens in normal terrain is you want to see a fairly even mix of all those things. If I had this data that I was looking at, and if I was just looking at it in plain view, I couldn't really see much about it. But if I turned those colors on and I saw that, like, three-fourths of this site was like way down here in blue, but then in one spot I have a real bright red area, then that tells me that that area has some bad data in it, that it's way higher than everything else around it. Now you have to, be careful, make sure that it truly is bad data. But then you would go and fix that and then rebuild your surface. All right, so, we got some things that looks kind of nice, right? But we've seen where it's incorrect, like down in these road edges. And you can even see by zooming in here, you can see how that's supposed to be a nice, crisp edge of a ditch. But it looks sort of stair-steppy, right? Because that's those flat areas that it read from the original contours. Remember, this is that file, surface file 1. Now, you've got some other things that you can do with it too. You can give it a vertical exaggeration, which means that you're going to see, it looks really deep. And be aware that that particular switch stays for the next time, even a different job. So, sort of keep your eye on it. You can drag this little yellow light source around so that it casts shadows. You can think of this as the sky. And if you put it right in the middle, that's like the sun being directly overhead. Put it all the way out on the edges, and that's the sun getting ready to set. And so it casts shadows based on that. You can change the strength of the brightness and the contrast. You can adjust those. Then you've got these buttons that are zoom in, zoom out, pan, all of which are sort of obsolete now because the wheel on your mouse does the same thing, okay? But here's how you control the visibility of where you are looking. On the view control tab, you have these icons, and this one right here that looks like an XY axis and a rotating around the Z axis type of hook. If you click that, that is the main control to be able to move, and it tells you there, a little pop-up, click and drag the left mouse button to control the view. Well, notice as I hover the mouse, it changes shape. When I'm near the middle parts of the data, and there's no real definitive boundary, but the cursor shape shows X and Y. That means that if I click the left mouse button and then move it up and down, left and right doesn't really do anything now because this lock over here is turned on. I could turn that off. Now I can rock it back and forth, left and right. I can rock it back and forth, up and down. But if you leave that one y-axis locked, it makes it really easy to orient yourself so that you can look at these things exactly the way you want to do it. And here's the technique. I'm going to change this color by elevation. I'm going to turn that back off. I'm just going to look at that. I'll turn off my contours. And let's go back to the view control tab. Let me set a little more brightness here to set that up. And I'm going to click that control button right there. And remember, this button toggles whether you can see it as a solid. This button resets it to plan view so that it's straight up and down. Then I'm going to click that control. And here's the way you move around to look at this in various aspects. If you think of this, I'm going to zoom out a little bit. If you think of this as you standing in your driveway, you're looking at your garage door, okay? And that garage door is one that you grab down near the bottom and you lift it up and it just rolls back into the top. So if I put this cursor down near the bottom of the data, now not so far that it turns into that Z shape, but keep it like XY, click and hold the button and push it up, just like you're raising your garage door. And if you have to go back and grab another bite of it, just let up on the mouse, click and push it up. And you want to lay it back fairly flat, okay? Not all the way flat, but just, you know, somewhat like this. Let the mouse button up and then put the mouse down on the bottom part of the data only. And now as you go, click the mouse and go back and forth, it only spins it around that orientation. So if I wanted to look, say, along that, what I know to be a loading dock, and I've got some problems with my data, I'm going to get myself lined up with it, be out here, and I'm going to zoom in. And now I see, oh, I got some issues there. And if I need to reposition my view, I'll just zoom back out a little bit, maybe spin it around, and I'm doing all this with the mouse. Okay, here's a nice view of it. And if I zoom into it, roll it up. So that will soon become very second nature to you. I look at all this and I see, well, that, you know, that part is problematic. And we'll do the same thing over here. We're going to talk about those road edges. I'm going to spin this thing back around. And if you need to reset it, I guess I need to turn that lock back on. If you need to reset things, you can go back to this plan view and try that again. So I'm going to look now down that edge of that road. Look at that. Look at what should be a nice crisp edge of the road. I see I've got all those little flattened areas because of the way those triangles formed. You can see that right there. Those are these little offending triangles. They are little high points that aren't really there, okay, because of that. All right. Now, a couple of other controls that you can do while you're in this viewer is on the model tab, you can add a different surface. You can either click on it, right click and choose add a surface, or you can click the button up here, add a surface. Well, let's compare that surface with, say, our EG2 surface. If we open that, it's going to come in with a different color, and they're going to be superimposed over each other right now. But on this model tab, I can go back to my EG1, open up this list if you need to. I'm going to right click that and say hide surface. And so now that's just the second surface. And I had to go back here to this view control and toggle this off and back on to get that garish red out of there. You can also go to the model tab and right click edit the surface properties, and you can change the color to anything you want. Let's make that a little smoother. Okay, so now that difference, you see, I still got all the problems internally, all these flat edges on the road, but I no longer have all of those triangles out here in the end. Okay, now, see, I still got this big ski jump out here. And you can see a lot of problems with this data. Although some people look at that and say, oh, wow, that's a great surface. And that's fine, but you know, you're working with errors. Now, let's compare one more. So back to my model tab, add a surface. And I'm going to add that final one that we made from the good 3D data. I'll now right click my second surface. I'll go back to view control, toggle off and back on. Looks like that was set to that color. I will right click this, set the properties, set the color to maybe be a pleasing little blue color. All right, so now if you look here, there's that loading dock area. Notice all these other nice features I've got. I see curves. Now I maybe have a little problem with the data there, but that's not very much to worry about because I can look all along these edges and I see I've got well-defined curves. Let's look back at the road. That might have been a place where one of those errors were. Right in here somewhere is that is that head wall that we fixed. Remember when we moved it around, so we've shaped that up a little better. But let's go back out here, get lined up, and now look down that road edge and look how nice and crisp that road edge is. Same thing over here. I can see that there's a little flat spot that it's not really a sidewalk, but it's graded flat, so you could walk along it. So a much tighter surface definition. And just look at it from this perspective. You can see the, you know, the bottom of this flow channel through that ditch. The pond is well defined with a spillway out of the pond, that loading dock. And now compare that one to, if I just double click it, it's the same as turning it off and on. Let me change this to a little brighter color. Oh, let's make the opacity not. So let's do it that way. There we go. And that one's opacity. There we go. Okay. So if I compare, look how nice and crisply defined my curves are, my road edges, my loading dock. Let's turn that off and turn this one back on, and you can, so you can't even see any curves out here at all. The loading dock is a mess. The road was a bit of a mess as well. Okay. Now it gives us enough information to do some volumetrics, but I mean, look at this in here in the original. Compare it to the final. See how nicely defined that is? So that is the basics of using the viewer. And it's the very same viewer if we say view, 3D view, drawing viewer, except now it says select things you want to look at. Well, maybe I just want to look at, say, you know, a few things in this corner, and I select that, or I could have selected everything. Now I've got the same controls. I can zoom up and down, roll back and forth. But on the model tab, I can also, you know, I can turn on and off different layers with these controls here. Same thing with text, but I still have this surface where I can add a surface. Let's add in the original surface. We'll come back here and toggle that to get the colors to look a little better. And now you see I've got the original things from the drawing that I selected superimposed on the surface, and you can see how nicely those fit. Okay. So you got some other controls down here. You can save to an image, you can print it. You can set particular views, from a particular location. So explore that, get to be familiar with that, because it's the best way in the world to evaluate your data. Because there's another way to look at this data before you start to model it. Let's say I'm going to turn all my layers back on now. If I get this file in from somebody, before I do anything to this file to start to model it, I'm going to just go to my 3D viewer window, the one that asked me to select entities. I'll select everything, pop it into my viewer, and I'm just going to take a quick look, and I'm going to spin it up and see if anything looks out of whack. Now, notice up here, I ignore 0. If I don't ignore 0, I can, if I uncheck that, you see, I can see the 0 things. Now, they won't, even in plan view, they don't directly superimpose because you're looking at a perspective. It's shrinking into the background. Okay, so that's one way I can see. If I look down here and I say, oh gosh, that needs to be a 3D, or if I see something up here that's at some weird elevation, I'm going to see it immediately visually, and I'll know how to fix that data. And you can even set a particular viewpoint and spin that around like this. And on my settings tab, you see this CAD button. I click that, it says, okay, your IntelliCAD view has now been set, so I can then exit, and there's my CAD view that matches it exactly. And I can reset that just by typing the word plan, hit enter one more time. Goes back to plan view. So a lot of great tools to be able to evaluate the data. Here's another one, and it's on the file menu of drawing cleanup, because sometimes you get stuff in, you don't know what it is. And if you hit the defaults button, then it checks on the things that are typically things that you need to do. Like you might need to remove some duplicate line work. You give it a tolerance, you tell it you're going to do it. You might want to remove any unused blocks, line types, styles, etc. All of these different things that you can do to the drawing. But the first one that I'd like to do is I'm going to hit the clear button, and I'm going to check this box right here. It says set elevations outside range to 0. And then I type in a number as my minimum and my maximum, because I'm going to know about where I am in the world and about what I expect it to be. So if I've got some of these lines that are drawn down at negative 10,000 feet, if I set this up to say 500 to 1300, because that's my expected elevation range, then anything that falls outside of that range doesn't get erased, but it gets set to 0 elevation. But now there's another way to, even before you do that and hit the OK button, if you check that on and hit the scan drawing button, it's going to read everything in the drawing, ignoring zeros, and tell you the minimum and the maximum elevations. If those numbers look correctly, you don't need to really do anything with that. Okay, so I had a client out in Wyoming, a big mining operation out there, strip mine, and he was trying to build surfaces for like a 36,000 acre site, and he was building it all from contours. Well, okay, that's fine for what his purposes were. He wasn't getting all the little edges of roads and stuff like that, but he didn't need them. But he would have, if you can imagine this site as being 36,000 acres, it was like the better part of a county. And so he had a tremendous amount of data, all this stuff, and he would grab everything and go to build the surface, and it would build it. And then, but it would draw these contours all kind of wacky, and it gets in this one area over here, and everything just blew up. You know, he had these giant things that looked like holes, you know, in his data. But he had never looked at that data in the 3D viewer. He never went to the file drawing cleanup and scanned it for elevation range. And what happened, the people that, either the people that gave him the data or he somehow accidentally moved all of the stuff in that one area to a elevation of like negative 40,000 feet. So all of this was up here in the mountains doing just fine. It got here and it just dove down, you know, halfway to China. And it very politely built the surface from him because that was the data. It was not zero, so it wasn't being ignored. And it just made some tremendous errors in you know, he wasn't able to spot what was causing it. And, you know, a simple trip to that scan drawing would have told him that, and it would have, it wouldn't have set him to the right elevations, but at least it would have, you know, set them all to zero, and he could have, you know, seen those. He could have spun it up like this. He would have seen all of those at zero. He could select those and make them a different color, and then know that he needs to set those elevations. And that's what he ultimately wound up doing. And it took care of it. All right, now, a couple of other techniques. Let's go back to freeze by pick and turn off those 3D break lines. And here's another sort of quick way to evaluate some things surface-wise. It's called a quick profile. It's on the surface menu of Kogo. It's on the profile menu of Civil, and it's down here called quick profile. And it's going to just cut a profile between some points that you show it, either based on screen entities in which I would select maybe these contour lines, or I could pick a 3D polyline that was already drawn, but I'm going to choose a surface file. Now, the file that you see shown here is, and sometimes you may see two file names. They are left over from the last time you run the command. So if you, and it doesn't matter, you know, it could be a different project. So I'm going to click the first button, and this is the one that's going to read elevations from and track along. So I'm going to say that first bad one. Well, no, let's say the second one. So we've got the trim on. And we'll say open. All right, and if we just do that, it's only going to look at that one surface. But if I say the second button and I want to look at the third one, I'm going to be able to compare the two. And then I'll say, okay. All right, now reading the prompts, it says, all right, pick a starting point, or I could use a centerline file if I've already made a centerline like we did yesterday, or I could have a drawn polyline. But I'm just going to click a point. I'm going to start here, and I'm going to go across this feature, click over here. Now I could keep going, but I'm just going to use 2 points, and I'm going to say okay, and it splits it into 2 views, and I can use the wheel mouse to scroll and zoom up here. I can point to the profile view and do the same thing with the wheel mouse. And as you can see right in here, for instance, right where my blue crosshairs are tracking, and I'll point back up here. I'm just hovering the mouse and using the wheel. So you see where I'm crossing in there, and you see the marker in the plan view corresponds to where I am in the profile view, and you can see that those don't match. There's that flat area. Okay. Now I can then take that. Now, of course, you've got vertical exaggeration There it is with no exaggeration. Here it is with, 5-time exaggeration. So you can really see the differences. So you see that white surface is the one that it's tracking, and that's the bad one. That's that one in their list. Right here's the example. Over here in this edge of the road, you see there's an actual curb line. You see the red line? That's my second surface, that good one. But the white line is what I modeled from the contours. Okay. Now, this is also somewhat real time, is if you have come into the command by picking points, you have this button over here called Adjust Alignment. If you click that, then it wants you to go up here and you're going to reposition that slicing element. Let me put this back to fit. Okay. So now I hit Adjust Alignment, and if you pick, you don't have to snap, but if you pick nearer to the midpoint of that, it's going to pick it up and drag it all across the sides. And you can come over here, and there you can see that big ski jump area. And then you pick again, and it puts it down where it was. Now, if I want that to be more perpendicular, I have to come back down and adjust alignment again, and then pick nearer to the end. And then I can swing it around like so. Pick the button again, maybe make it a little more perpendicular. And now you can get a sense of, right in there was where those weird contours were. Okay. So it lets you get a good indication of where there are problems with the model development, if you've got something you can compare it against. And again, you can see it's just real time, slice and dice of that data. If I want to look across that pond, I'll click it there, click the adjustment again, stretch it across like this, click it one more time nearer the middle so I can just sort of drag. Now I can see right here, it's not too bad. I've got a berm that I didn't really pick up, and the bottom of that pond, because I chose contours on the first go around, that's this white flat line because it was going from one elevation to the same elevation all the way across. And the pond is actually a little bit deeper than what my model suggested it was. But you can see, like I told you earlier, here's where it's too high, up here's where it's too low, and across the site, it will tend to balance out in terms of volumes. But you miss out on things like, we'll come over here, and I'm going to, wish you didn't have to do that in 2 stages or 3, but now you can see in here the difference in, you see the curves, the red lines is where it should be crossing, and that's where my red surface down below here, I've modeled the curb correctly. Same thing right in here, but you see the white line is that original contours only. Same thing right here is the other end of that island. You see it just sort of sloughs off right through there. It's too low here, too high there. Again, by volumes, it tends to balance, okay? Now, one of the things that you can do also, if you have gone into this with the by means of picking a point or picking points to set up your sample line. Once you have that thing set and you've moved it around, that's what you want to look at. You can either save this and it will create a profile file. You can draw it. So if I choose draw, I've got all of these different things that I can set up, drawing a grid, put it in paper space, set my grid intervals and all that kind of stuff. I'm just going to take the defaults right now and say, okay. I'll say okay to that. And now I'm going to come over here and plop it down. And you see, I probably should have changed my vertical scale. What am I at? I'm at 2 feet and 20 feet. So I'm at 10 times scale. So I probably would have done that a little better to keep these surfaces the same. I'll just come back up here and pick one across the other. Yeah, that's the one I want to do. I will now draw that. And this time I'm going to, instead of go 2s and 20s, I'll keep it 20, but I'll only make it, I could set it to 20, it would be 1-to-1. Let's do that. Let's just make it 1-to-1. And say okay, say okay. And now it's going to draw like this. And you can see, and again, you can control the color and the grid spacing and all that, but this line represents the good surface. This line represents my bad surface. And you can see right there, that is, you know, what is that? 13. So that's 20. So that's like 1308 up to 18. So that's like a 10-foot drop right there that it completely blew across and missed. Okay. Again, it's just a little picture of it. I can erase it. But that gives you some techniques to find the data, to look at the data, what problems you can get if the only data you have are contours, but some of the things you can use to mitigate some of those errors. Let's do one more surface build. So turn off the 3Ds, but let's leave the contours showing their original contours. I'll go back to surface, triangulate and contour one more time. I will use the inclusion, exclusion areas. I've already got it drawn. I'll go ahead and use that. And now look down here where it says adjustments for source data of contours. If I say minimize the flat triangles, and interpolate some flow paths going down valley lines and interpolate ridges and valleys. Okay, now this is far from perfect, but it does help. So if I say okay, oops, no, I want to change to a different file. We'll make that one EG4. And now I'll say okay. Now read the prompts again, select entities, but it says pick the inclusion polyline. So there's that inclusion polylines. No more inclusions, no exclusions. And now the data, type all, let it go. And it's going to build, it's actually going to draw some contours because I didn't change that part yet either. Notice it took longer to compute this time because, and it also came up with some errors. Oh. I have my ignore 0 unchecked. Nope, it's checked. Let's clear those. Maybe uncheck flow paths. That might be what's causing it. Oh, I erased that drawn polyline because that was considered part of that surface, and I told it to automatically erase. So no biggie. I'll get triangles out here, but we'll let it go. Still have some crossings, 8/10. I don't see anything that's crossing there. I'm going to just say exit at this point. And now let's go up here to these known problem areas. And if I look at my contour line is this white one. I'm going to put it in the back, and I see there is the green one. So see how it eliminated that flat area? So that is a very useful switch. Now, right here's a condition where it did not eliminate it. Okay, so there would be a flat there, but those other ones were handled pretty nicely. I come up to here and look at there, that big ski jump is gone. I still have some problems. I don't really see the curb data. I see a little bit more definition with my contours. And it looks like they are actually, let's put mine in the background. So my draw order goes to the back, and there's there. So yeah, it sort of followed it a lot better. And if I compare the two with some of my techniques, I'll do a quick profile. I'll use a surface file. I'm going to set the first file to be the let's use the first one we built from the 3D data, the really, really good one. And the second file, I'm going to set to be the bad one. I'll say, or not the bad one, but the one I just made with those little switches turned on. And I'm going to go from here across to here and be done. And now, even with, let's go up to as much as a 5-time vertical, I see some areas like right there along that curb jump that I missed. Mine is the red one, the white one is the really good one. But notice like over here in the ditch area on the left, it really modeled that very nicely. Now, if I adjust this and I'm going to push, whoops, get closer to the middle. I'm going to push it right down to that. So you see that flat area now is starting to show up down in that corner. And I get back past that one and it starts to resolve itself back down to something a little much, a whole lot nicer. Let's do a, put this down here and do a bit. All right. So you can see that whereas it's not perfect, that switch under surface, triangulate and contour, that tells it to minimize the flat triangles and interpolate the ridges and valleys. Those are useful if the data you have are contours, if that's the bulk of your data. But again, that's the worst possible data source you can use, but sometimes it's all you have, okay? So now, one last little bit, have a little bit of fun. I'm going to erase all those contours. I'm going to freeze by pick their contours and their labels. I've got them all, yep. And remember I told you as long as you have the file, you can always create the contours. And that is a command on the surface menu to contour from a tin file. So if I do that, the tin file that I want to use is EG3. That was the really good one. So I'll select that file. And now notice I've got triangulate, contour, and labels just like I did. I don't have the select tab. But I've got some controls, the ones that make sense for me. There's others that aren't shown here. I'm going to turn this erase previous entities back off. I'm going to uncheck inclusion and exclusion areas because it will stop at the edges of the surface anyway. I'm going to uncheck these two adjustments. I don't need that because I'm going to be reading a file, not creating. I'll go to my contour layers. I'll keep those the same. I could change the interval if I wanted. Here's my labels. And make sure that I'm hiding under the labels. And let's set this down to say 300 instead of 500. And let's make our text a little bit bigger. Let's make it 0.125. That should be good enough. We'll say okay. So it's reading it, drawing the contours, and labeling the contours. And I can zoom in here and I see that, and there's my label. Now that was done with a style called standard. I'm just going to change that font to be let's see, Roman S. So it's just set to IC Roman S. But standard is now a little bit better defined. Okay, so there it is. Now here's why I had you set those things to break. I really probably ought to redo that since I've changed the text style. So contour from 10 file. Let's take everything by default like I had it before. I do need to erase those again. Say okay. All right, so now my gaps are a little bit more suited to the text. But now zoom in around some of the text that you might see in these resulting drawn contours. What can we do with those? Let's say I wanted to move that from, say, here to be over here on this segment. Well, you can do that. You can simply select that. Notice when I select it, it says 2, text and the wipeout. So there's a background colored rectangular box around that text. That's what makes it hide the contour. It also hides anything else that might be underneath it, like curb lines or whatever. But so I could select that and I could, move it over to here, but then I have to rotate it to match the line and do all that kind of stuff. So I have a tool on the surface, and it is a contour utility. I'm going to come down here and move contour along label. When I choose that, it says down here to select the contour label to move. I could change that to copy by typing the letter C, but I'm just going to move it. So I'm going to pick this guy, and then I'm just going to move the mouse. I'm not snapping to anything. I'm just going to reposition it and click. All right. I'm still in the command because I still have my little pick box going, so I could work my way around here. Now I'm going to go from here, say up to here. And a really nice feature is I want to get a place where it should flip the text. Seeing it, if I'm from here, if I choose this one, I go around to here, see it flips it. It doesn't just rotate it around. It always keeps it reading correctly. So if I were to take this and notice as I move it, when I start to change, see how it flips right there? It no longer takes that front edge to the 1295 and keeps pushing it out there. It flips it around. So now the one is in the back and it winds up so it always reads correctly on the sheet. Okay. Here's a place where you might want to, fix that guy. Oops, even that's in a bad spot. Well, let's put him up here. I know that would be a good spot. There we go. All right, so once you're done with that, you can hit enter and finish the command. So that's just some of the techniques that you can use. You would, definitely fix some of this in here with that. You probably, Well, I have no idea why they're so often here, because that's not that distance. Let me see what that distance is. Standard distance. So that's only about 60 feet. My contour from 10 file. Here's my same file. Here's my labels. I said go 300 feet, but this scalar is 7.5 inches. 60 times what my drawing scale is. My drawing scale is 40, so that'd be 240. 7.5 times 40, 280. That doesn't make any sense. Anyway, it's something to do with that interval. It's a new switch. It used to just be a distance interval. Now it has this scalar thing, and it's not documented in the help system, so I don't know what to tell you about it. That one. No idea if that's going to do anything. Now, see, that's still there and there, there. One last little try on the thing here. So it puts it back to 7.5. If I make that 500, let's make that. That's a little better. So here's this one. I don't see another one on that contour line until I get. Let me isolate these. All right, so that's a little better from here around to here. That's probably closer to 500 feet. So I don't know what that number is for, that scalar number, but I do know that I've got some cleanup that I would probably do under my contour utilities, move along the label, put that guy up here where it's not down here on that weird spot. Same thing over here, just some cosmetics once you've plotted your contours. Okay, store the layers, and there's your finished stuff. Now, I know we are well overdue for a break, so let's do that. I'm going to, I do want to show you a couple of other little tricks here, especially you geologists that might find this of some help. If you, is everybody good to go for about another 10 minutes, and then we can call it a day if you'd like? Who's good with that, or do we need a break? If we need a break, let's go take a break if you haven't already. What do you think? Hello, anybody?
That's kind of up to you, Ken.
Well, I can give you your break at the end of the class if you guys are comfortable, but if you're sitting there, about to die because you need to go take care of a biological function, I don't want to keep anybody from that if you haven't done so already. Well, let's take a look at something else we can do with this. I'm going to erase by layer again to get rid of all of those. I'm going to then turn everything on, go back and freeze my original break lines. Let me go ahead and also freeze these pink dots. There we go. So this would be like what the finished map looks like. Okay, now, I told you this was from a real job site. And this job site happens to be in the south zone of Pennsylvania on NAD 83. So if I go to my settings menu and choose my drawing setup, and it looks like it's already set for me. So that part's good. I didn't have to change it. But if it's not, if you'll set it to State Plane 83 PA South, then that has defined the basis of these coordinates. You see down here in my status bar, you see those coordinates are really large coordinates. Those are state plane coordinates. Now, what can I do with those state plane coordinates? And I think we can do this on the survey tools. If I go to GIS, no, they don't have it on this directly. All right. I'm going to switch to the GIS menu. You guys might not have that, or if you've got the Civil Suite, maybe you do. And some of the mining companies typically get that tool set. So just switching that, again, settings, Carlson menus, GIS menu, if you have it. If you're running the demo version, you'll have access to it. I'm going to go to the images pull down. And if you have Google Earth installed, I'm going to say place a Google Earth image. So it now says select an output file. So this is going to be a file that it's going to create and save. So I'm going to be in my working folder, and I'm just going to call this project area. Okay. Now, it wants to know the extent of my map, either by the screen, or if I type M for map or click on that, it puts me in a little browser that I can go out and, sort of like picking something, from the internet as to where it is in the world. I'm just going to say by screen. That's the default. It's in angle brackets, so I hit enter to tell it that. Now pick a corner for the lower left and a corner for the upper right. So I do that. And I can choose high resolution, medium or low, whether I want the aerial map or a road map or a combination or just the terrain. Let's go ahead and choose the aerial photo. And the checkbox here is the layer that it's going to go on. It's called imagery, Google Earth, aerial. Now check to place it in the background. So it's as if you placed it, select it, and moved to back. Now say okay. It's going to go out and actually contact Google and bring in the image of that location that matches Google Earth. Now, that may be useful in your mine planning, so you know where your roads got to go and that kind of thing. But there's a couple of things to be aware of when you're doing that, and one of those is that Google Earth is not necessarily the world's most precise. If I zoom in down here, see these pink curve lines? Now those are produced from a photogrammetric survey. They're actually survey grade quality. But you see the curve line back here doesn't match it very well, right? Same thing right here. If I look at this pink curve line compared to the photograph, it doesn't really match it real well. There's an inlet, and then you see the inlet in the photograph. So, there's a couple of misfits, again, right in there. Now, for planning purposes, this is well more than adequate. It shows me, yeah, I'm in the right part of the world. I can turn that on and off, work with it. However, if I need it to be a little more precise, There's one other tool. And again, I've got to go to the settings menu, Carlson menu, and I'm going to run CADnet menu. Oh, the new update did not install the model. Anyway, what you would have seen, it has some tools to do rubber sheeting. And you basically will identify a point on the photo and show it a point in the data that belongs to. And you do that for several different points where you got some little mismatching. And you do it all around the site, you know, get 10 or 12 different points to tighten it up. And then when you hit go, you will see this photograph actually warp itself into fitting these drawn elements, wherever you've told it those are control points. It's a process called rubber sheeting. And it's just as if that photograph were a rubber sheet. You see here, I would take the corner of that concrete and set it back to this purple curb line. All right, so I'll have to check on that license availability in the demos. It used to be available for that. Anyway, those are just a couple of extra contour, or not contours, but modules that you can use if this becomes part of your work. It can be very helpful. Again, once it's selected there, you see it is nothing in the world more than, and you know, it's an image. See up here, it's just a plain old CAD image. You can select it, save it, delete it, you know, do whatever you, you know, freeze it, thaw it, do whatever you want to do with it. All right, so, but to make that work, you have to be established in a known coordinate system. And then when you bring in Google Earth, even if Google Earth is in, you know, meters, UTM, NAD 27, it does the transformation on the fly and it makes it match your data set. Now, notice there's also, you say, I said place Google Earth. Well, you've got all these other image controls. You can get an actual really precise aerial image that's been orthorectified and it'll fit this data like a glove. But just Google Earth is, you know, it's one of those close enoughs, but it's not exact. But it's a nice handy little tool if that is in your workflow. So I would recommend you take a look at that if you need. Now, we can tuck that drawing away. No need to save anything from that. And I want to, at this point, I think we're just going to call the actual hands-on bit a bit of a day. And I want to talk to you about the rest of this, these exercises in here for you to look at as your homework. All right, so we've been doing a lot of the stuff that you see in here. We learned to use the viewer. Here's an example of those shrink wrap entities with those convoluted edges. The differences in the contours, where you can see the contours. Some evaluation tools. There's this surface file viewer. There's that color by elevation if you'd like to use that part. And it steps you through. It tells you, like, here, next choose the icon that looks like a set of thick XY axis arrows with a hook arrow, and that's your spin control. Here's that quick profile exercise shown over here on this, if I can get it to highlight. There we go. So starting here, use surface quick profile. But this workflow exercise, this is sort of a recap summation of everything that you've learned in the whole process. And here's what it is in a thumbnail sketch. We have a drawing. In fact, we have a drawing that has these points drawn in the drawing. So we would open up that drawing, and that drawing here is called example 1. And we zoom into that and we see some descriptions called B, 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 and then we said B dash toe, B dash toe. So, and those are the only 2 descriptions in the file. Okay. So it's B and B toe. So if we're going to model that as a stockpile, you know what? Let's do that real quick. Not the entire exercise. I'll go back and finish talking about that, but I do want to show you to compute volumes. Let's go back to Carlson and open a file, and let's use this example 1. Okay, so this is all that's in this file. Spin it up and see, yeah, there are elevations. And when I say spin it up, what I'm doing with that quickly is I'm holding the shift key and I'm pressing and holding the wheel on the mouse and pushing it around, and then I reset it by typing plan. All right, so I've got these points, they have elevations, and if I'm going to compute the volume of this stockpile that's represented by these points, what do I need to do? How would I compute a volume? Because don't we need 2 surfaces to compute a volume typically? You got an existing ground and a final ground. And the answer is sort of multivariate here. If we build this surface, and I'm just going to go back to my survey menus. Go to triangulate and contour. I'm going to go to the contour tab and uncheck to draw contour. I'm not going to draw them yet, because I can always draw them later. I'm going to go back to triangulate tab. I will ignore zeros. I will write the file. So I'm going to select, and I'm going to put this one, I'm going to call this one SP-1 for stock file 1. I'm not going to have any inclusion exclusion because I would let it, I'm going to pull this down to say a medium reduction. We'll draw on the surface boundary, and let's turn off the erase previous. And that's really all I need. I'll double check my selection, make sure nothing's filtered. I'll say okay, I'll say okay. It says select the points and break lines to do it. So if I do that here, there it's built my surface, and I see my boundary looks pretty good. It goes all around the B toe points. Okay, so there's some places where it might have overshot or missed one. Looks like it's pretty accurate with that. So that part took care of itself. So there's my boundary. I'm going to verify with my surface viewer, my SP1, and I see there it is. Now it's really chunky. There's not a lot of data controls in there. You see, that's just point to point to point. So I've got a, I've got these, I've got a point up here and a point down here and a point down here. So, that point might be a bad point or something. You could do all kinds of refinement to that, but accepting that it might be correct. How do I then compute the volume of that stockpile? Well, what is the volume of a surface is the difference of that surface compared to another surface, right? That's the volume between those two. Well, what is the surface that this stockpile gets compared to? And it's 2 things, possibly. One could be just some average elevation that's around the bottom, and just call that a plane and figure out how much material sits above that plane. But this particular set of points from, the B toe points, which start at, looks like 2000, starts at 2000, goes to 2029. If I look at those points, this points, ooh, where do I go? I don't have any points in here. Okay, if I select that, so I've got this example 1, but it says existing, but it's not in my list of files. Okay, so if I want to get those into a point file to be able to list them all, what do I need to do? Anybody? Remember what happens when things are out of sync between the drawing and the coordinate file? We go back to our points menu, point utilities, and we're going to update the coordinate file from the drawing. But now it's going to complain that I don't have a coordinate file open because all I did was open the drawing. So it now wants to know the coordinate file to process. Well, I need to go to new now, and it's going to match my drawing name. I'll keep it at that. I'll say open. And I'll leave the asterisk as my wildcard and say, okay. Now it wants me to select any Carlson land development desktop, soft desk, inroads, Eagle Point, geodometer, Leica, or microsurvey points. I'll just type all, I'll hit enter there, Carlson points. Now I found 80 points. Now I've got them if I list points. And let's go from 2000 to 2029 to 79. So these are all the, oops, there's a 29. So that's within the range, but look at my minimum Z. So I range from 390 up to 397. So I could figure out an average elevation of say 393.5, right? So my surface menu, here are my volume commands down here is, that's for grid surfaces. But my volumes by triangulation, I've got 1 surface volumes or 2 surface volumes. Well, 1 surface volume, there's my stockpile as my file to check. And it now says, well, what do you want to do? I can either, if I set that elevation at, what was it, 393.5, and say, okay, I can use the inclusion boundary here. I don't really need to. We'll just take, I'll uncheck that. I'll leave the shrink and swell set to 1. I'll say, okay, here's my numbers. I'm going to dump it in the drawing over here. And we'll use that to compare with. All right, so that's what it thinks it is if I just use an average elevation. Now, if I choose to use the surface perimeter, that's going to be as if I had taken this 2D line and made it into a 3D line and built a surface out of only that thing, and I did not include the points in between. Okay, so that's as if it's picking up that stockpile and it's figuring out what the bottom looks like. Now, what really happens, I could be sitting over top of a giant pit in here and I have no way of knowing. In that case, I'll never be correct and there's no way of doing that. All right, so if I go now to surface and choose volumes by triangulation, again, 1 triangulation surface, there's my surface, and I'm going to choose the perimeter of the 10 instead and say okay. I'll hit okay. I'll choose to write into the drawing, and I'm going to come over here and put this one right here, and I can compare those two, and I see that I've got a slight difference in what I'm seeing here is cubic yards, cut volume. Yeah, I would say a slight difference. So you see this tells me I've only got, 16 yards of cut, just a little bit of cut in there. 2,700, 2,600 of fill. So the same thing happened, except when I compare it to that average elevation, you can see that really wasn't all that accurate. Okay. Now, if I'm out in Kansas somewhere, that might be okay, because that tends to be sort of flattish out there, although it's really not flat. It just happens to be even. All right, so this first one was by an average elevation. This second one was by the perimeter. And let's look at what it did using that perimeter. So I'm going to select this line and delete it. Now let's draw a 3D polyline this time, making sure that prompt for elevation is unchecked. And I'm going to say OK. And pick a point or point numbers. Now I know that it went from 2000 to 2028. 2000-2028. And then I'm going to type C to close. And so now I have a 3D polyline that is all the way around that stockpile. So I'm going to make a surface out of that. I'll go to surface, triangulate and contour. And this time I can say use the inclusion, exclusion. I will pick that line that I drew. And I can also then ignore zero. Let's see, that's about all I really need to do. Make sure my contouring is off. I'm going to change my file name by choosing select. And I'm going to call that SP-base. I'll say okay. I'll pick the inclusion perimeter. There are no exclusions. And now the points and break lines to triangulate. Well, I could go through and pick all these points, but this 3D line already has those points in it. So all I need to do is select that. I hit enter. And now I've got two surfaces that I can see. Here is my first one. If I look then at the bottom one, which was SP base, I can see I've got a little bit of difference in those two right there. But you can see, there's the bottom part of it. I do have a little slight convolution in there. I'm not so terribly worried about those edges on the outside edges. Let me just verify. Turn this guy off. Let's go back and reset this. And let's come back. So now I see that that's really nice and flat. So that probably does represent, represent that surface bottom pretty nicely. Okay. So now if I choose volumes by triangulation, this time 2 surface volumes, it wants to know, it's asking us what is the existing surface file. I'm going to choose the base as my existing ground. I'll choose open. It now wants to know what is the final surface. So that's going to be my SP1. I'll choose open. Here's my inclusion, no exclusions. Again, the same dialogue here. I'm going to put that in the screen. I'm going to put that one, so my mouse comes back right over here at no rotation. And now look at those. So that also slightly differs, but it's a lot closer. So there's that little bit of cut. That's where those edges turned up on the corners. But see, that compares much nicer than, say, this other over here. Now, for this little bitty surface, you know, these numbers are almost meaningless. But, you know, if you're working on a giant quarry layout or something like that, you're going to, you know, these numbers are going to be close to, these two methods will be closer to the same than this one with an assumed elevation. Okay. Now, that's all we need to do with that. And that's going to be looked at in this exercise. See, and it also shows you, there's a way to draw a 2D polyline based on, you know, point descriptions. So you get to see a couple more options on those draw commands. And then, you know, how to set up, say, the stone texture on your resulting stockpile. And this talks about computing those volumes. There's that same type of thing, the process, step 1, 2, 3, 4. And we looked at those different means of calculations, the different reports. And then here's the design part of it, where we are going to create a new surface based on this design pad. And we didn't really get a chance to go into that part very deeply here or even at all. But it's basically, you're going to draw a shape, you're going to tell it a surface to use to, you're going to set an elevation, you have it target the surface. It's going to, in this particular example, we're making a borrow pit. So we're setting the floor at an elevation, and then it climbs out of the floor and hits that top all along that edge. Here's some of the view conditions. Here's the merging of these two surfaces with this merge 10 command. Okay. And then some different ways, once we have those surfaces created, you know, how do we draw the resulting contours? This is the case, I'm keeping the originals, and here's my proposed contours. So it looks like a contour map, or a, you know, a contour construction map. We also can use that to trim off the existing contours on the inside. And then we draw our line, we drape that on the surface, we see the surface here, we design on top of that a roadway profile. Again, it steps you through all of these different conditions. And then we have that road, we draw it into our drawing, like this up here, as a 3-dimensional polyline, and then we offset the edges down 2% over a particular distance and make that into a surface. We take that outside edge and we tell it to seek the existing ground surface. And so that makes a surface like that you see here that can be contoured. And then you see it's finally merged in to this right here. And these little kind of stray lines here, those are just sort of some glitches in the contour. And this pad bottom is actually sloped a little bit. But you can see you come up that surface or up that access drive, and you come into the borrow pit. And when you merge all those things together, and that's the final end of that, here you can see coming up the drive, coming into the borrow pit, here's the actual merge, and it cuts down into the borrow pit. So I'm going to touch down right at the that same elevation. And then it cuts out that bit in the middle. It fills up that part that we went over, with some fill material. And of course, from there, you can calculate the volume differences based on those things. So when you get a chance as you're working through this kind of stuff, go through that final exercise, and that will basically start on page 37, and it's in the index as this final exercise, putting it all together, and it goes through all of these different things that we've talked about along the journey. Okay. Whew. So with that, I had hoped to let you guys go a little bit early, but at least we're not going to hold you late. All right, so we won't be late like we were yesterday. Questions? Again, I know it's a lot to take in, but anybody have any questions that occurs to you, or if you do not, please remember, you got my email, to stay in touch. Now, once the videos process, I will post those up to my YouTube channel as unlisted videos, and you guys will be the only ones with the links, so you'll be able to get them. And again, we will have a gap in this